Hey everyone and welcome. So in this section we're now going to learn about Matplotlib, which we're going to use for plotting. Matplotlib is an amazing library that we can use inside Python, and it's going to, well, allow us to essentially do all sorts of really cool visualizations. Now to go about installing it, I'm on the Matplotlib website right here. We can go and either go into the installation instructions, which are going to be really easy. All we're going to need to do is just pip install matplotlib. So pip install matplotlib. It's essentially the same thing we did when we were learning Python and we installed Pygame, where we use pip install Pygame. So here we're just going to use pip install matplotlib. If you have multiple versions of Python, you may want to use pip3 install matplotlib, which you would then put into your command line if you're on Windows, or into your terminal if you're on Mac. Again, if you want to refresh on how to use pip, make sure to go back to the Python section, check out the installation part there, and how we went about installing Pygame, and then just replace that with instead installing Matplotlib. Now, throughout the rest of the course, we're actually going to use a different environment. So when we're doing Python, we use the idle environment, which is a really great thing to just kind of get started and get coding. But from now on, we're actually going to use the Anaconda environment. And the reason we're doing this is because so many of the things that we want to use as data scientists, or just generally when we want to like visualize or analyze or do all sorts of, related things, Anaconda has all of this stuff for us. So the whole point of Anaconda is to make all of this scientific Python a little bit easier and, have everything there so that we need to do less management ourselves. And so I would recommend that you go over to anaconda.com and you go to the download section. And again, this is all completely free. And you're just going to want to download this distribution. Just wait for it to install. It's a little bit bigger. The reason it's a little bit bigger is because it has so much stuff pre-installed already. And just make sure you get the Python 3.7 version. We're going to be working in Python 3.x, so 3.6, 3.7, that's what this whole course is going to be in. And as the Python versions go up to 3.8, 3.9, so it should all still be compatible with all of that. Just make sure you get the Python 3. Version, and then you can also, for me it's defaulted to Mac because I'm on a Mac, but of course if you're using a different one, it's going to default to whichever one that is. Yeah, so just go ahead and download the Anaconda. I would really recommend it. It's much easier to use in my opinion. I prefer it much more, and we need to deal a lot less with extra installations. And once you have Anaconda downloaded, you can open this thing called the Anaconda Navigator. And it would look something like this. We're going to be using Spider as our environment. So I've already installed it, but in case you haven't, it will have this green button here, install. You're just going to want to click install and install that and just wait for that to install. And then you can use the Spider environment, which is what we're going to be using. And that looks like this. Now it's going to look a little bit different for you. The main reason is just because I've increased the font size of my editor here. So this is where we can write all of our code. And then there's another section up here about like performance and stuff. So I just clicked X on that section and I just have my whole console available here. And in this case, this is very similar to what we had in idle. We can just do some shorthand code like, this type of stuff. But here we can actually type out longer programs. And if we want to run it, we just press the green button here, which will execute the code in here. And so, it's really easy like that. I really enjoy it because it's so user-friendly. It's very easy to get like a great overview of it. And actually when we run our stuff, we can then also reference it in here later. But all of that we're going to see. The whole point of Anaconda is, for one, I think it's really nice, user-friendly. It has a lot of stuff pre-installed for us already, so we don't need to worry about installations. And I generally also just like the setup and how it looks. So of course you can stick with the idle that we used for Python. You just want to make sure that you go along when we need to install the new libraries. Just go ahead and use the method that we used in the Python course. Otherwise, I would recommend you download Anaconda. It's completely free. It's going to be a little bit bigger, about 500 megabytes or so, but just download that and then launch the Anaconda Navigator. And then from here, you can install Spider, which is what we're going to be using, and then it looks like this, and you'll basically have the same thing that I have on the screen then. But of course, this is just a different coding environment, and if you want to stick with idle, or if you even want to use something completely different, that's all totally fine. You know, the best thing to use is whatever you feel most comfortable with. I personally prefer Spider from Anaconda, and that's why I generally use it. And of course, it's really nice to just have a lot of these packages pre-installed for us so that we don't need to constantly worry about downloading new packages and stuff like that.
Hey there, it's Max and welcome. So in this lesson, I want to show you how you can use Jupyter Notebooks. Although for the rest of the course, we're mainly going to be using the Spider environment that we've just recently downloaded. But Jupyter Notebooks are also very popular among data scientists, and they're especially nice for prototyping and analysis. So I also want to show you how you can install and use Jupyter Notebooks in case you either want to use them, because they're also very cool to use, or you want to follow along in Jupyter Notebooks, or you've heard of them and you just want to know what they're about. So to get them, we're going to go to our Anaconda Navigator, the same place where we also have our Spider installed. And then you can just click here to install the notebook. If you haven't installed it, or if it's not installed for you, then the button will be green like it is here. You can just hit install and wait for it to run. And then yeah, you can click launch here. Now when you launch your Jupyter Notebooks, two things should happen. First of all, you should have a pop-up that comes up, which will actually take you to the Jupyter environment, which is going to be in your web browser. Now the second thing that's going to happen is a terminal window is going to open, which contains information on your current Jupyter session. So let's go through each of these, and we'll come back to this one a little bit later. So first of all, what we have here in the terminals, you'll notice our address here is just on the local host, so our local machine. Our current port here is just 8888, which is going to be the standard one. Unless you have something running here, then it will open in a different port, but this is going to be the standard port that it uses. Now what you'll also see is we have here our file paths. So you can see, for example, I'm in the desktop, and then in my coding with Max folder, and then in my Jupyter folder. So you can actually also just use this UI to move around the different folders that you have on your machine. And you can also see here, if you want to go back a folder, you can just click up here to go back, or you can also click this double arrow, which will just take you up one folder location. All right, so let's go ahead and learn how we can create a Jupyter Notebook. So what we're going to do is we're going to click on New here, and we're going to click here on Python 3. You'll notice that you can also create things like folders or text files, since all you're doing is just adding something into your folder. So for whatever I create here, regardless of if it's a text file, a folder, or a Python 3 notebook, it will get added into my Jupyter folder that I have within my Coding with Max folder that's on my desktop. So let's go ahead and create our notebook. I'm going to create a Python 3 notebook, and you'll see it opens up in a new tab here. All right, so you may have just seen up here that we said our kernel is starting. We'll get to the kernel in a second. Let's first just talk about how we can use our Jupyter Notebook. So first of all, up here we have our title, or the name of our Jupyter Notebook. We can change this to whatever we want, and this will just update the name of our notebook file. So for example, we can call this my first notebook, and then this notebook here is going to be solved as a Jupyter Notebook. If we go back, we'll see here we have our updated name, and you'll also notice the extension for a notebook is .ipynb for IPython notebook. And then we have the green icon here, which we'll also get to in a second. So we have our notebook here. Now what you'll notice about notebooks is that we have different cells here. So let's go through how we can use these cells and how they behave. So in these cells, we can just write regular Python code. For example, I can create a variable a, and I can assign it the value 5. Now I can either click up here to run, or I can click Shift Enter. Personally, I like hitting Shift Enter because it's quicker to run. So let's go ahead and run that. So now you can see I ran it, and what actually happens when I run with Shift Enter is it will also create a new cell for me. If you want to create more cells, you can go up here, and this will create new cells. And if you want to remove extra cells, either because they're not necessary or because they're blank, you can click on these scissors here, and that will take them away. All right, so what's the point of this though? How does this work? Well, every time we run a cell, our state of the notebook is saved. So for example, up here I've declared the variable a and I've given it the value 5. In my next cell, I can access the variable a. If I hit Shift Enter, it will print out the value. We can see here the value of a is 5. All right, so let's do something else. Let's create another variable b, and let's give it the value 4. And now I'm going to print out b, and you'll see it has the value 4, but actually what happens is I can go back up and I can update some of my cells. For example, if I want to now print out a and b up here, I can just print out a comma b, and actually the printing out, the way it works in Jupyter Notebook is the last line, if there is an output, you don't even need to write print. You can write print around here, and it will print it out, but you don't need to. You can also just leave it like this, and it will actually just print out the resulting last line if there is some sort of output. Now you'll notice that we're up here, which is below our variable definition, yet we have access to our b variable. And so this is something that's very cool and important about Jupyter Notebooks, and it can be really good, but sometimes it can also be dangerous. What you'll notice on the left here is that we have numbers next to our cells. These numbers basically represent when the cell was run, in what order. So this was run, basically the first cell that was run. Then we don't have a 2 because this is actually a 2, but we've run it again since. So the next thing that was run was this one, and so when we run this one, the state of what we have here is saved. For example, a is equal to 5. Then we printed out a, nothing was saved, or well, we just printed out a, so there's nothing else to save. Then we ran this one here, which is our 3, and we set b equal to 4. So now we have a is equal to 5 and b is equal to 4 saved in our state. Now we run this one, which prints out b, and now the next thing that we run is up here, but our current state has a and b defined. So we can still access it even though we're a cell up higher. So why is this cool? Well, this is really cool because imagine you have a piece of visualization code up here, and further on down or further on up you have some definition for maybe some sort of function or data generation or data reading or parsing or whatever. You can just rerun the same cell and just create different visualizations as you're updating your data, which is really, really nice. So for example, if we just create something else here, let's create a loop, and let's just say for I in range 5, and let's just give the value, well, this is not going to work well, so let's go for I in range 10, and let's assign the value, or I guess it's 19, let's assign the value a to I, and then we're just going to run through all of this, imagining this is some much bigger code, and then we can go back up here, and now our a takes on our latest value. So for example, let's say we're reading a file, or reading a series of files, and at some point there's an issue. Now, the state of where we last were was actually saved. So let's say we were reading 5 different files, and on file name 3, our code crashed. We still have access to file name 3, because if we have a variable that takes on the name of the file during each iteration, then we can access it, and we can actually directly debug it, for example, because that was the last state that was saved before our cell crashed. And then of course, you have other really nice things, again, like I talked about, like with the visualizations or the data updates, that you can make changes and you can just rerun the same cell blocks, but as the data is changing, then you're actually using the same code, but your data is updating, and so you'll get different results, which can be really nice because you don't have to rerun code. And it can also be really nice because, for example, if you download code, or if you download data, or you read in data and you do a bunch of processing and the processing takes a long time, then you have your data in your cell. And so then you can just continue to use it and you don't need to reread it in every time you run your code. So for example, here, let's just say A is a really big dictionary, a really big list or something. We don't need to reread in A or recreate A when we want to use it later on. Let's say we want to dive into parts of our data. We can just directly access A because it's still saved in the state, which means we don't have to wait very long to read or reprocess data, because once that's done, the final state of that object or the final state of that variable is saved, and we can just use it in any of our other cells here. And so that's really cool. Again, if, for example, you want to do visualizations or some exploratory analysis, you only have to read in or download your data once, and then it's saved in the state of your Jupyter Notebook, and then you can just continue to use it, and you don't need to wait for the loading and processing part to run every single time you run your code. So that's really cool. However, there are some easy pitfalls you can fall into with this. Something or some issues that this can cause is because we're using saved states, this can actually cause or result in inconsistent performance. So for example, let's say we write some processing code up here, and then we have some visualizations, and then we do some data updating, or we slightly, do some extra processing or some rounding or something, and then we rerun our visualizations, and maybe we delete the data or we delete the updating that we had down here because we no longer wanted to use it, or we didn't see its relevance anymore, or you came back to the project a little while later and you just thought it wasn't necessary anymore because it was so far on the bottom. When you rerun your code, you will get different results because you were dealing with these saved states. So with Jupyter Notebooks, it's very important to think about the order of things, the order of execution, because each cell that you run updates the states of all of the variables, and you're always using the latest states. So if you're playing around a lot and changing up your data, and you're changing your code and you're not leaving old versions of it, then you may not be able to reproduce the results that you had if you made some changes and then either updated them or made additional updates to changes that you made to your data, and then made additional updates to that, but you didn't save the intermediate update process because you overwrote the code, you wrote over the code and you changed the code, then you're not going to be able to reproduce your results, which can be a really big problem. So something to always keep in mind is that when you're using Jupyter Notebooks, make sure you keep track of how you were running your cells so that you can always reproduce your results. Now, an important question, or you may be wondering, okay, well, how can I do that? A good way to test this is to use the kernel up here and just click restart and run all. And if I run this, you'll notice here I'm going to run into an error immediately because first of all, B is not defined. So already this shows me a problem, which means I should probably move this down here. So I'm going to insert this here, and then I'm going to restart and run my kernel again. And now you'll notice that it goes through smoothly, and you'll also notice that up here I'm still printing out 5, not the 18 that we had before. Now, of course, you don't want to continuously restart and rerun your kernel because that kind of defeats the whole purpose, but this is how you can check if, your order of operations is solid. Of course, you can always just go into each of the cells and just hit, for example, Shift-Enter and rerun them all individually, but it's faster to just go into the kernel and do restart, either clear output, which will just restart our kernel, which we'll talk about in a second, what a kernel is, and it will just clear everything. Or we can just restart and run all, which will restart our kernel and it will run the whole thing. So things to consider. Of course, again, you don't want to do this all the time, but it's important that you keep track of major changes that you're doing that you want to keep. And you also should not just be overwriting your data without keeping track of how you were doing the overwriting. When you're making changes to your data, make sure you use a clean version that you can reproduce up here. And when you're making changes, make sure to store it in a new variable so that you're not overwriting your original data that you loaded in and processed. All right, that being said though, Jupyter Notebooks are awesome to use because they make prototyping and exploratory analysis super fast, because you have all of these saved states and you don't need to do a bunch of reloading, a bunch of reprocessing. You can just continue where you left off with your previous state. So just be aware that this saved state can both be a blessing and a curse, and make sure that you don't run into these problems where you're doing updates to your data and then you're overwriting that code, and then at some point you don't get reproducible results anymore. Make sure that the major changes that you're doing are reproducible and that they're in the correct structure. So you can also, of course, take things here and you can take this code and we can add a new cell up here and we can paste it here if it's important for us to keep that structure. So that's one thing to be aware of. And then the other tip that I highly recommend is when you're changing your data, change the resulting or put the resulting output into a new variable so that you're not overwriting your data in the original variable. That way you can test around with changes, but you don't have to worry about overwriting your original data and leading or getting to places where your results are no longer reproducible because you were just lost up in all these saved states, and at some point the data was just changing and you overwrote the code and weird stuff happened, or you forgot what order you ran all of the cells in and you can no longer reproduce it because you don't remember how you were doing the processing, and it's not in the linear format that when you just restart and run all, that it will give you the same results. All right, so let's quickly talk about kernels. When we open a Jupyter notebook, we get a kernel assigned to it, which is basically an instance that will run our Jupyter notebook. And so the kernel is also what keeps track of the saved state and everything. So when we restart our kernel, for example, that will basically wipe the slate clean and it will restart this instance from scratch with no saved data anymore. So that's really nice because, then any of the changes that we have and we want to get rid of because we no longer want to be in the state and we somehow changed our data and it's not the way that it was supposed to be originally, we can just restart our kernel if we wanted to just get rid of all of our saved states and just kind of restart. Then the other thing that we can do up here in the kernel that you can see is we can interrupt. So if our code is running too long, or if we feel like there's something weird going on, or if we made a typo, we can actually interrupt our kernel and that will just stop it in its tracks, which again can be really nice because it just kind of gives you this interrupt where you can then make changes to your function and basically then restart again and continue on with that cell one more time. Now, the other thing that you want to think about with kernels is that because kernels are instances that are running, when you open a Jupyter notebook in a tab like this, it will give it a kernel and it will start a kernel for it. So you want to make sure that when you're done with your Jupyter notebooks, that you go here into the kernel and you click shut down. Now you want to do this just because it's not nice to have a bunch of kernels running in the background that are just using up resources that aren't being used. So you can see also what kernels are active by going in here, and whenever there's a green symbol here, that means you have an active kernel. So if you close the notebook, but you forgot to shut down the kernel, then you can also go in here and you can click shut down, which will shut down the kernel. Now you'll also notice we have other options here. For example, we can duplicate our file, or we can edit its name, or we can, delete it. So again, just like we have in our actual folders, when we're going through folders, we basically have the same options here with the UI, and you'll notice that if you have several IPython notebooks, sometimes these will be gray, which means there's no active kernel, and other times they'll be green, which means there's an active kernel running for it. So for example, we can shut it down here, and this will shut down our kernel. We can open it up again, and once we open it up, it will start up the kernel again, as you can see here in the top right corner. And if we go back here, we'll again see we have an active kernel. And then the same thing if we want to, then good practice would be once we're done, we just shut down our kernel and then we shut it down. And as you saw with the warning, that also means that our states will be lost. So that's something important to keep in mind. And you'll also see here there's no kernel running right now. And you'll see here that now this notebook doesn't have a kernel associated to it. If you want to start the notebook up again, remember, now that we don't have a kernel, the slate has been wiped clean. None of the state has been saved anymore. So if we run it again, we're going to run from scratch, because even though the order is still here, if I try to run this cell, it's going to give me an error. And actually, it's stuck in a loop right now. So let's just go ahead and restart our kernel. So if I try to run this, you'll notice that A is not defined. And that's because our kernel has been shut down. And so the state is no longer available. So I have to start from scratch again and basically create everything like this. So something to keep in mind, of course, that our notebooks are working through kernels. And if we shut down or restart our kernels, that will wipe our slate clean. One more cool thing that you can also do with Jupyter Notebooks is that you can also not just write code blocks, but you can actually go in here and write, for example, Markdown, which is just going to be text. So here we can have just text here. We can have headings, which will, for example, be headings. And you can see here how the process goes. Let's say this is a heading, which looks weird, but when you run it, you'll notice that there's actually formatting added, And because Markdown is, well, Markdown, if you know how to use Markdown for GitHub, for example, you can actually also add here some Markdown syntax. And then again, if we run this, we can see here we can also add some formatting in like this. Now, the reason this is cool is because if we're doing some sort of analysis, we can actually directly add annotations, and we can add, for example, some descriptions. So we can add here some sort of like title maybe, and then we can say here in this project, or in this cell, or in this series of cells, we're doing, you know, and then whatever, and you can just add some descriptions, or you can add your thoughts about why you're doing it or the assumptions that go in, or you can also just point out some notes to, you know, keep in mind or to watch out for, or point out things in the visualization. And that way, so you can see here, if I run this, for example, it will all be formatted. And so this is really cool because this allows you to create reports where you're basically writing code, and as you're going through it and producing results, you can actually add more proper like text and annotations and explanations, which makes it a very readable thing that you can pass on to other people, where, you know, you can very easily communicate your work. That being said though, usually at some point, if you want to take your results and maybe deploy them somewhere, at some point you're probably going to start thinking about moving your code from a Jupyter notebook into a Python script. And so what you can do is you can just take the individual cells here and, for example, just copy paste them into a script. But then here, of course, it's again very important that your results are reproducible, and that when you restart and rerun your kernel, you're going to get the same results. And then once you've finished your prototyping, your exploratory analysis, or whatever else you're doing, you can then take your implementation and just take all of the cells and put them all together into a Python script. And from that, go from a prototyping environment, which is what we can have inside Jupyter, to a more development-focused environment, which is what we have, for example, when we go into Spider. Finally, I also just want to mention that if you want to shut down Jupyter, just shutting down the kernel isn't going to do it. You can actually, well, you're going to have to go into the terminal tab here, and then you can stop the Jupyter session here by either exiting out on the terminal or hitting Control-C to do a keyboard interrupt, and then that will actually shut down your full Jupyter session. Hey there, it's Max, and welcome. So I just wanted to show you something real quick before we go into the actual visualization. It's just about the settings. So if you're using a new version of Anaconda, or specifically Spider, you may see this notification here when you're running your visualizations. And don't worry about this code, we'll get to this later. And so usually what can happen is when you're running your visualizations, then you're going to see something that looks like this here. So this may also likely pop up for you instead of this. In case you don't have this thing here popped up, the way that you can get to it is by going into the view, then going into panes, and then here going into plots to show it. But in our lessons, we're actually going to have the visualizations pop up in here. So the way to make them pop up in here rather than in a separate window is once we've opened this, and again, we do that by going into view, then going into panes, and then over here selecting plot so that it's on. Then we can go up here and click on these three bars, and then we're going to uncheck mute inline plotting. And then to close this here, I'm going to click on here again, and I'm going to click close. And so now when I run this code, we can see that the visualizations here are actually produced inside of our console here. So just, for one of those setting things, I'd recommend that you do this just because it's easier to kind of see like this, so that when you're running your visualizations, you can directly get them into the IPython console output here.
Hey everyone, and welcome. It's Max, and in this tutorial, we're going to look at scatter plots. So to start off with scatter plots, and the library that we're going to use here is going to be Matplotlib. We're going to import matplotlib.pyplot on the very top, and we're going to import it as PLT. Now this .pyplot section is pretty much all of the plotting stuff that we're going to use for quite some time. So this matplotlib.pyplot section is really, it's going to be a very big part of all of this plotting, but since it's a very long name, we're just going to kind of shorthand it to
plt, so that we can just call plt dot whatever and use everything, all of the methods, all of the other classes and instances that are available to us inside of this matplotlib.pyplot import. All right, so before we start plotting these scatter plots, we're going to need some data first. And what I've done is I've actually downloaded some data from the Bundesliga season, so soccer data, and I've made a text file that just has 2 lines. The first line is home team goals scored, and then the second line would be the away team goals scored. You'll have access to this text file too in the description, so you can just go there, look at the resources, and just download the text file. I'll also include a link to where I got the data from. But right now, let's just go ahead and use it. So to open it, I'm going to use this with statement rather than just opening the file into a variable, because this with, it's really nice because I don't need to remember closing the file later. It just kind of takes care of all that for me. So I'm going to say with open, and now I'm going to open the text file. So the text file is called goals.txt, like this. And I'm going to open it in reading mode, and I'll just open it as goal data. So that's the temporary name that I'm going to use for it. And now again, the structure of the data is going to be that the first line is going to be the home team goals, and they're all separated by spaces, and then there's a new line at the end. So what I'm going to do is I'm going to make this simple, and I'll say home team line. So that's going to be the first line. We're going to go into our goal data file, and we're going to read the first line of the file. So that's all going to be stored in here. Then we're going to just change the structure of this. So the first thing that we're going to do is we're going to take away the \n at the end. So that's what this .strip does. If you're not familiar what it does to strings, pretty much if you have a string and you call .strip to it, it would take away this if this is the trailing character. So a short example I can say, or that we can trust here, is we can just say x is equal to hello, and if I just print out x and then call x.strip o, then here we see that the o was just taken away at the very end. And so that's what this will do here, and it's just going to take away that new line character at the very end, since we have several lines here. Okay, the next thing that we're going to do is we're going to split this, because every goal is separated by a space. So we're going to split this, and this is just going to give us an array, and each element is then a goal, or a goal value. So the only thing that we now have to do is we're going to save this in kind of our final variable, which is going to be our home team goals, and that's where we're going to store the data. And what we're going to do here is very similar to what we have here already. So the thing that we have here is pretty much, if you imagine that all of our data is in a text format, so it's going to be like 6, 3, 2, 9, something like this. And what we've done here with the splitting is we've converted this into an array, and every time there's a space, we've made it a new element like this. Now the only problem is we've imported this as a text file, so all of these are not integers, but they're strings. So what we need to do is we need to convert all of these strings into integers. And we're going to write a nice little shorthanded loop in here, and we're going to say this is going to be a integer version of x for x in our home team line. So really what we're doing is we're creating an array, and each element in this array is going to be the integer version of x, where x is going to go through this home team line value by value. So if you want to see a short example of this, I can just put in here some test numbers like this, and 1, 2, and 3, like such. And if I make y equal to the same process that I'm doing here, so the integer version of x for x, oh, well, that was a bad name, so let's do that. Let's call this z, the integer version of z for x in our X array here. Then we see what this does is it converts these strings pretty much into integers, but really what it does is it goes through this array value by value, element by element, and it saves this in this new array, y, and it turns the string value here that we have into its integer format. And so really that's exactly what we're doing here. Now we're going to do the exact same thing for the second line, and the second line is going to be our away team. So we're just going to copy paste everything and change home to away. So we'll just change all of these here, but it's the exact same process, and switch that over to away. And because of the way that file reading works, we can just leave the read line here, and it would just read the second line for us. Okay, so this is how we went about just importing our data. We've got here our home team goals, which is just a list or an array that has all of the home team goals for us, and then we've got the corresponding away team goals in here. To make sure it works, we can just print these two out if we like. So these are going to be our home team goals, and the next print is going to be our away team goals. And so if we run this, oh, my bad. So what happened here is we had an empty character, and it can't convert this to a integer, and what happens is there's actually an extra space at the very end that we need to get rid of too. So if we try this one more time, there we go. The error that we had is that the whole line was not just, it didn't end on a new line character, but it was a space and a new line character. And so we had at the end pretty much an array element that was just an empty string, and it couldn't convert that to an integer. So we just had to take that extra space at the end away. But that's not something that you have to worry about. That's just kind of the way that I save the data. That's pretty much what caused this here. Okay, anyway, so as we can see, we've got our two arrays here. The first one is our home team goal. The second one are the away team goals, and each element corresponds to the same match. And we've got each of these nicely stored. They're all integers, as we can see. All right, so we've got our data, and we can go ahead and start plotting it now. So to plot, we're going to start with a very simple plot. So we'll do scatter plot, as the name already suggests. And to do that, we're going to go into matplotlib.pyplot, which we've imported as PLT. And we're going to call a method called scatter, like this. And scatter, we can just do this very easily. First, we can just put in the x and y variables. So depending on how we want to plot it, maybe we just want to plot the home team goals on the x-axis and the away team goals on the y-axis. Really, we can just put them in like this and say, these are our home team goals, this is our away team goals, and the scatter method will actually automatically kind of identify that these are the x and y, because these are going to be the default inputs. But if you want, you can also specify the x variables are going to be this, and the y variables are going to be this. Now to see the plot, we're going to add one more line. We're going to say matplotlib.pyplot.show. And now you don't necessarily need this if you're just doing one line, but we're going to add it in anyway, because if we're doing, if we're adding several plots, which we may see later, then we want to be able to, say this is when we want to see the graph. So this plt.show is just going to say, everything that we've added to this plot right now, let's just see it. So if we run this, this is what we see here. We've got our home team goals on this axis. We've got our away team goals here on the y-axis, like we've defined, and then we've just got some plots, some dots that show, the scores that turned out. Now, there's probably a high chance that there was more than one game that ended up 1-0, and so we don't actually see the difference, or we don't see the number of times this happened. We just see that there was a point here, and we don't know if it was once, it was 5 times, if it was 10 times. So this is one of the things that these scatter plots, for example, can't show us, but we can see this general distribution. So just to show you, we can take away these x and y values. They would be inferred by the scatter method, and if you just scroll up and compare the two, it's going to look the exact same. But if you want, or maybe you want to have this one be the y and this one be the x, then it would just be flipped around as we see here. So you can add it in if you like.
but you don't need to. Okay, so this is the basic scattering. There are some extra features that we can, like tune. And the first thing that I want to look at is going to be the size of these dots that we have them here. And so we can change the size of the dots. So right now, let's try to make them a little bit bigger. And we can just say the size is going to be, and it's just going to be an integer number. So if we have the size be 25, we see this looks to be like the default size, so maybe we can move it to 35. We can see the dots are getting slightly bigger, or we can change it to 50 to make them even bigger. And so this helps us kind of identify the dots a little bit nicer. It's a little bit easier to see than these ones, but it really doesn't make that big of a difference. You want to be able to increase these dot sizes. If you have a very large scale maybe, and you want to be able to pinpoint different things, maybe you just want to amp up the dot sizes so that it's easier to see. But there are times when you have graphs and there are just a bunch of dots on them. And in that case, to be able to resolve or to be able to distinguish these different dots, maybe if everything is really, really cluttered and very close together, you actually want to make the dot sizes a lot smaller so that you can distinguish two different dots that are very close together. In which case you can decrease the size and the dots will become a lot smaller. And as you can already see, the colors are harder to identify, but you'll be able to see the individual dots. And so depending on what you need, if you have a lot of data that is very close together, you maybe want to reduce the size a little bit so that you can see the individual dots if that's what you want. Or if you have, like a big graph and you want to be able to identify the position of each of the individual dots, you maybe want to amp up the size a little bit so that they stick out a little bit more and it's just easier to see them. So that's how you can manipulate the size. Of course, we can also change the color, and a parameter we would use for this would be C. And there are many different ways that we can input a color here. So the first way would just be to put in a string. In this case, for example, I can just do a shorthand for R, which would be red. And maybe I increase the size a little bit to, let's put it back up to 70. So here we see all the dots turned red. I can also type in red, or I can type in green, or G. So this shorthand doesn't work for everything. There are some predefined values. So it's going to be your basic colors of red, blue, green, cyan, magenta, some other ones. We can also type in black. So you can write out the colors and there would actually be a lot more colors available to you. Yeah, so that's how we would do it with a string. We can also use hexadecimal values if we like, or these kind of color strings. So for example, we can say like 0f, 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 which would give us another black color, as we see here. So all of these color strings is what they're called. We could use too. Or if you like, you can also use RGB values. To make sure you use the right RGB values, what you're going to have to do is you're going to have to use it as a nested list or a two-dimensional array. And then you can put the RGB values inside here. And these RGB values are going to be between 0 and 1. So 1 would be the kind of full end. It's pretty much scaled down from 0 to 255, so it would be 0 to 1. So for example, to get red, I would do 1, 0, 0, RGB, red, green, blue. And so that would give us the red color here. And I can change this up or put in the numbers however we like this. I can also do an RGBA, so add in an alpha value, in which case I would just add a fourth element in here. And this alpha value is again going to be between 0 and 1. And I can do something like 0.2, which would add a lot of transparency. Or I can do like 0.9, where we have very little transparency added. So all of these things are things that you can play around with.
Now, something else that's nice about our visualizations about the scatter plot here that we can do is rather than setting the color to a single color, for example here, red, and getting the graph that we usually do, we can also set this to an array or to a list of colors. And so if we put in here a list that's of the same length as our input variables, then we can actually get unique colors for each of our dots. So, for example, let's say we want to put in here, just the easiest way that we can create a list for this is maybe just taking the values. And so what that means is every single value that we have in here is going to be color coded, or it's going to have its own kind of color code mapping. And so every value that's in here is going to represent the same color. So if we run this, then we can see here anything that has the same home team goals values is going to have the same color, which is exactly what we can see here. Now we can also put in, for example, the away team goals and use that for the color mapping instead. Oop, getting all this overlay stuff here. So now we can see that everything along the same points in the y-axis are going to be the same color. And so we can actually also define colors with lists here. Now this is a simple way to do it by just visualizing the colors and having them, you know, be the same color for every kind of value in our x-axis or every kind of value in our y-axis. That's one way to do it, but there are also other things that we can do to like customize this. For example, if we want everything to have a different color, then we can use the range, and then we can create a range of numbers equal to the length of our home team or our away team goals. They're going to be the same length because of course they need to be for us to plot them. So in this way we can create a range of numbers for our home team and our away team goals. And if we visualize these, then we can see here everything is going to have different colors in this case. Now we can also do more complicated things. For example, we can create a function called distance from 0. And in here we're going to take the home team goals, we're going to take the away team goals, and what we're going to return is going to be the distance from 0 that we have here. So we can return, for example, our home team goals squared plus our away team goals squared. And if we want to get the actual distance, realize I put a semicolon here too, then we're going to need to use the square root, and the square root we can get easy access to if we import math, and then we can do math.square root. So from this, we can then have this new function called distance from 0, put in here the home team goals, the away team goals, and return the squared, or return rather the distance from the 0 point here. So that means we can create a new color values, or we can create an array called maybe just colors, but of course you can call it whatever you like, and we can iterate over maybe the length of our list here. So we can say for I in range length of our home team goals, and then we can say, okay, so to our colors, we're going to append, and then we're going to call our distance from 0 function. And in here, we're going to put the home team goals, which is going to be the home team goals with index I. And then we're also going to put in here our away team goals, the corresponding element, which is going to be our away team goals for index I. So we're going to loop over the length of our home team goals, which is going to be equal to the length of the away team goals because we need them to be equal for visualizations. And then for each color, we're going to just use our distance from 0 function, and we're going to provide as input that element for the home team goals as well as that element for the away team goals. And then our color values here are going to correspond to the distances from 0, for example. And so then we can just take this colors array, which is going to now be the same length as our home team and our away team goals, and we can put this in here. And if we run the visualization, now we can see our values here are color coded based on how far they are away from this origin point, for example. So you can see that you can get very creative with how you want to do the colorings, and through that again you're able to convey more information, because now we can easily gauge distance, for example, of how far away different data points are in different parts of our graph from this 0 value, since you can see here we're getting a color gradient. So this is also another very cool way that you can use this colors argument. Now there are two other cool arguments that I want to show you. The first one is going to be the marker, which is going to be the symbol that we use here. So this we can change, for example, and there are different values that we can put in here. But for example, we can put in a star. And what the star will do is every marker here is going to be a star, or we can put in this power symbol, which is going to make everything be a triangle. And so there are different markers that you can use, and so if this is something that you want to play around with, the easiest way to find all of the different marker options would just be to quickly Google Matplotlib markers. And that will give you all of the different options that you can put in here depending on which marker you maybe want to use for your visualizations. One more thing is also the alpha. So we can set the alpha directly if we use the Rgb values, but we don't always use Rgb values. So we can also set the alpha as a separate parameter, and this will then count for all values. So for example, if we want to use an alpha of 0.7, then we can put that in here and we can run it. And so that's going to apply this transparency. And to make this even more obvious, let's apply a lower alpha. And so we can see here, this again applies the transparencies. Now, one thing that you'll notice is that the values where there are more values underneath will be less transparent than the ones where there are less values. So you can actually see these values have less of an alpha, or these values have less transparency because there's actually more data points underneath, right? There are likely many games that have 0-0 or 1-0 or 1-1 scores, and the ones that are 6-0 or 5-2, those ones are much less. And so this is a nice way, because in scatter plots, it's hard for us to, or it's basically impossible for us to see how many points are lying in the same place. But if we set an alpha, now we can see that there are actually more points lying in these regions here because their transparency is less, and in these ones there are less points because they have a higher transparency. And so we can also use the alpha as a way to kind of inform ourselves as to how many values are stacked on the same point.
Hey everyone, it's Max and welcome back. So to continue on, before we really get into the bigger details of data visualization and the advanced things, I want to make sure that all of the basics are covered, especially for this matplotlib.pyplot library. And one of the important things that I want to hone back into is this plot creation and how it really went down. So what happens is if we call this plt.scatter, a lot of stuff is being created in the background for us. So for example, if I just run this, we see that there's this automatic box for me pretty much, or it's called a figure that's been created for me, or this axis, and then all of these grids are there. So we've got our X and our Y axis that have been created, and it's been auto-formatted and everything. So what's happening is basically when I call this and I haven't created anything yet, it just kind of creates some default things for me. And one of the things that I want to get into now very quickly, just so that we kind of know what's going on, is something called a figure. And that's really this bigger thing here. And so actually what we see here, this would be a subplot technically of the figure, but the figure itself is just one plot. But the whole figure would really be all of the plots that we wanted here. And so I'll also look into later how we can add more plots. So maybe do some side-by-side plots or plots stacked on top of each other, all of these things. But to do that, we first need to have a figure where we can add all these plots into. And so if we haven't created anything like that, as we can see, we don't really have to worry about it because Matplotlib automatically creates default things for us to make sure that we can do all of this. And this is also nice if we just want to have a quick graph. We don't want to deal with all the nitty-gritty details. But sometimes it's also nice to be able to manipulate these figures because we want to do more stuff to them. So we'll look at how we can create these figures now. And it's actually quite simple. We'll just go into matplotlib.pyplot, and we're going to call a figure like this. And that's basically it. So if we want, we can just use this to create a figure. And if we do it like this, there isn't really much point to it because this is pretty much being done automatically anyway. What we can also do is we can save this figure object into a variable, and we'll just call it fig, short for figure, so that we know what our figure is referring to. So we can save this figure object in here, and then we can later do stuff with it or reference it or add other things to it. So one of the other things that I would like to quickly touch on though is
one cool thing that we can do with this figure is we can change its size. So if we want, we can define this fig size parameter, and in here we're going to put a tuple. So it's going to have the format width and height in inches. So we can make our figure bigger. So let's say we want to make it a 10 by 6, and I'm going to make it 10 by 6, so just so that you can see it's going bigger in one direction than it is in the other. And I can save this, and I can run, and we see our figure got bigger this way, as well as in the up direction, but it's stretched more in the width, and so that's because we defined the width to be 10 inches, and the height we have here as 6 inches. And what you can also see is that once we've created a figure here, it actually carries down. We're kind of using it as the figure for all of this. And we stop using the figure pretty much when we say this plt.show. And so afterwards we wouldn't be using this anymore. Or if we create a new figure, so let's create a second figure. This one will have the same format, but here we'll have the fig size be 6 by 10, so we're going to have it be higher in height and more dense in width. And so if we save it, so now we see we've created a figure here, but now we've created a second figure here, and because this is the most recent figure, this is going to be the figure that we're going to use until we pretty much switch figures. So we've created a bunch of figures here, but the most recent one is the one that we're going to use unless we somehow say that this is not the one that we want to use. And so we see now we have this very high figure that's not as wide as the one that we have above. Now, important to note that this thing that we see here, this is actually a plot. So this is not the figure itself. The plot is kind of put into the figure. So the figure is the frame for all of this. And to show you what I mean with that is I can actually add a face color to the figure. So I'll just make this red so that we can see. And what we see here is this is actually the figure, everything in red behind, and then we've put this plot onto it. And so the plot is going to kind of stretch to meet the dimensions of the figure. And we can change the figure, for example, to make it wider, and the plot will adjust accordingly. But it's important to know that I've put this plot onto the figure. And so this is also important to know later when we add several plots onto a figure, is that this plot is this, then if we have like two plots in here that we want to have side by side, this plot will actually be, maybe half the size of the figure or a little bit less so that they can fit in next to each other. So the figure that we have here is not, this plot that we see here, but it's actually kind of the background that this plot has been put into. But us manipulating the figure size kind of manipulates the plot that we put on here, and it stretches it out to match the dimensions that we've given the figure. So that's what we can see here. All right. So now that we have these two figures, and maybe there may be cases where you want to have a lot of figures because you want to have different plots, you also want to be able to switch between figures. And so the way that we can choose between which figures we want to use is we can actually give numbers or names, if we like, to our figures. So we've defined the fig size here. Now if I want, for example, I can put in here the number 1 at the front and then just put in here the number 2. And so this gives each of my figures a number that I can use to reference it. So if I just try this and run, nothing much happens. So the color changed, that's just because we removed the face color, but the size of the figure stays the same. If I want to now use the first figure that I'm using here, what I can do is I can just go in here and I can call the plt.figure, and then I'll just call it by the number. And we can see here the dimensions change, so now I'm actually using figure 1. Similarly, I can type in here 2, in which case I would use figure 2. So depending on where I am, maybe I want to switch figures, and I can do that just by doing it like this, calling it plt.figure, and then putting in the number that I've designated, in which case that would switch to the appropriate figure. Now, I can also change these rather than from just being an integer. I can give it names. So I can call it my first figure, for example, and this one I'll call second, and so rather than calling 2, I can put in here the name second, which would get, well, the second figure, or I can put this name in here, which would give me my first figure that I've created here. And of course, you don't have to give it these names. These are just example names. You can really call it whatever you want. So like this, of course, would still work. You just have to make sure that the names that you're using are actually the right names. And so that's, depending on where you are, depending on what figure you want to use, that's how you can also easily switch between the different figures. Hey everyone, it's Max, and welcome back. So now we've got a better understanding of these figures. So if you remember, figure is kind of our background that we've put this plot into. We're going to look at adding, or what axes are and how we can add different axes. So an axis pretty much is this thing here. It's the thing that we put onto the figure. So the figure is kind of like our frame, and the axis is going to be what we put into it. And so right now we're not going to change around figures too much. We'll just stick with using figure 2. We're not going to comment this out just because. So we'll just use figure 2, and we'll look at how we can add several different axes and what that means for us and everything. So to do that, we're going to go into our figure 2, which, or our second figure, which we've saved in this figure 2 variable. And we're going to use a method called add subplot. And what we can do here is we can put in pretty much it's going to be the number of rows, then the number of columns, and then it's just going to be the index of where we want our axis to be. So I'll explain this more in a bit, or I'll explain it through examples. So really we can define the number of rows and the number of columns that we want to have in this figure, or kind of how we want to split it up. So for example, if we want to make 9 figures that are split up into kind of like a 3 by 3, so we've got 3 rows, and we've also got 3 columns, so we've got 9 figures, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what we can do is we can say, well, we want to add a subplot that's going to have, it's going to be in the position of 3 rows, so we're going to split our figure into 3 different rows. We're going to split it into 3 different columns, and the index is just going to be really the plot that we want. So it's going to have to be between 1 and 9. So it has to be between 1 and the multiple of the number of rows and the number of columns. So it can't be bigger than the multiple of the number of rows and the number of columns. So I can just write this here, or maybe I'll write it on the next line. It has to be between 1 and this value. Okay, so that's important to remember. So we can't put 10 here, for example, because that doesn't make any sense. We've split this into 9 different subplot areas. We can't put it in position 10 because that doesn't exist. But we can choose what index we want, and we start counting, and we start at row 1, and then we go column by column. So we'll go 1, 2, 3. So 3, for example, would be here, 2 would be here, 4 would be down here, 5, 6, 7, 8, 9. And of course, if we add more columns like this, then it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'd start by the row, and then we go through the row, column by column, then we go to the next row, and we go through it like that. And so that's how we would be counting everything. So for example, if I want to put a axis right here, I'm going to put it in the 3, 3, 2 position, and I'm also going to save this into an axis, or into a variable that I'm going to call ax1, so pretty much the first axis. And now if I save and run, well, actually we get a much smaller plot, but if I add a couple of other axes, so for example, I'm going to add a second axis that I'm going to put at, let's say, position 5. Then we see that we're getting this figure here. So if I put in here a face color, just so that we can observe the figure and how we're adding axes into it. We're taking this figure and I'm adding axes into it, and I actually don't have to be consistent with these things. So for example, I can say I want to have 3 rows and 1 column, and I want to put this in the 3rd index, so that would be for going row and then column by column, so that'll be row 1, row 2, and row 3, so the 3rd index would be the bottom row. if I do something like this, then we see, and this is actually a better representation of really what's going on, is our axis 1 here is this thing up here. So what we've done is we've taken this figure and we've split it into 3 rows and 3 columns, like this, and we've created an axis that would take up this position here. Now we've added a second axis where we effectively split the figure into 3 different rows with only 1 column in each row, and that's what we have right here. So we've got our figure here, and our axis here, and since this is the last axis that's been created, it's kind of the one that we would refer to if we just use this standard PLT. So the last figure that was created was figure 2, and since we're adding the axes to figure 2, the last thing that we actually created is this axis 2, and so that's where we're putting that's where all of these plotting commands pretty much are going into. So that's why we see all of these graphs down here. If we want, I can also put it in the middle though, so I can maybe move it here instead, so that would be position 2, be run row up, and we actually see that the figure kind of adapts to the size, so we don't really need the 3rd row, and hence it kind of disappears. I can, however, add it in still, just so that we see how all of this formatting works. So we see I've created this axis right here, which is, if we split the figure into a kind of 3x3 grid, it's the second axis. Then I've created another axis, if we split our figure into a 3x1 grid, so 3 rows, which I have here, but I didn't draw anything into it, or I didn't put anything into it. And then I've created the final axis, which is if we split it into a 3x1 grid, and it would be at the second position, so that's what we have right here. Now, important to note, there can also be overlap. So for example, if I take this one, and also you'll notice I'm changing the variable names because I want to save these in different variables, otherwise I would just be overwriting things. If I put this in position 5, for example, so position 5 is going to be, if I split this into a 3x3 grid, 1, 2, 3, 4, 5. So that's going to be right here, which is going to overlap with this one here. So here we split it into a 3x1, and we've used the second row effectively, and so we're going to have an overlap of axes here, and we'll see that like this. So that's something that you maybe should be aware of if you're adding axes in different formats, that there can be this overlap and it may not look as pretty. But yeah, so that's just something that we should be aware of. But this is how we can add these different subplots into here, and we can kind of see the figure, which is what we have here in red, how that adapts, and really how the figure is kind of serves as the canvas, and the axes are the objects that we put in here. And we can split up all the space that we have allocated here in our figure, so we can split it down nicely into these grids however we like. So something else that I'm going to show you is I'm just going to use a short for loop, and I'll say for I in range 1 through 10. And I'm just going to create all of these 3x3 axes and put them all into our figure. And so what I'm going to do is I'm going to say add the subplot, and I'm going to add the subplot I. I'm not even going to save it anywhere. I mean, if I wanted to, I could create an X list or something like that, and I can actually append it to this list, and so each element in the list would be an axis. I don't need to do this just if I want to reference it later, but really I'm just doing this so that I fill out all the axes. I pretty much add an axis in each of the ones, but I'm not plotting anything into it. But just to show you that I can do this, so we would see here I created a bunch of different axes. None of them I plotted into. The last one I created was the one at 3, 3, 9, which is the one here. And then I've decided to plot some things, and we see that the plot has been populated here. If I move this inside of the for loop, I would get the same plot in every single axis here, because every time I'm creating one, because I've now created another subplot, that's the one I'm going to be referencing. And so we can see then, if we plot into it, that's the one that we're going to be plotting into. And of course, now I have this list, this array that has 9 different axes into it, so it's going to be axes 1 through 9. So starting up here and going all the way down here, that's how it's going to be ordered. So that's how you can go about the different axes. One more thing that I wanted to mention is that maybe I'll take away, oh, never mind. So I'll just want to show you how we can select a different axes. If we want to create a bunch of axes before and then select one that we want to use, either, of course, you can reference the axes. Like if I wouldn't have blurred this out, you can always reference this axis floor and then scatter into that. And the format, the syntax may change a little bit, but generally you can do it like this too. In this case, it would be like I would go into my list, I would access maybe the 4th element, which would give me the 5th axis, so this one here, and I would scatter into it. And so we can see that I can plot directly into this one, or if I choose this one, 0, up here, I can plot directly into that one. So that's one way that I can plot into it. Another way, I can keep with this PLT syntax, and I can say plt.sca, so set current axes, and now I just need to reference the axes that I want to set as the current axis that I want to use. So for example, let's say I want to use this one here as my current axes that I want to do all of my commands into. I'll set the current axes, and this is actually the 3rd index, so the 4th element in my array, so 1, 2, 3, 4. That would set this plot here, this axis here, as the current axes, and everything after this would then go into this axis. And if I just copy and paste this and now change the index, then everything, now that I've set a different axes, everything after here, maybe I'll change the transparency so that we can see, everything after I change the axes would then go into the new axes that I defined. So index 8 is going to give me the 9th element, which would be the one down here. So we'll see we have one plot here with lower transparency, which is what we have here, as well as one with a very or higher alpha value, which is what we have over here. And so this is how the figure and the axes work together, as well as how you can select your current axes. Either you can set the current axis as what you want it to use, or you can reference it directly like this, so you can plot into it directly like this. Should give us this one down here. So these are the different ways. Something that's important to note is that if we use this format here, the syntax here sometimes may be a little bit different. But yeah, it's important to know what figures are, what axes are, and we'll also be using these a lot more, so you become a lot more comfortable with them. But it's also kind of important to know how Matplotlib builds everything up in the background, because it's going to allow you ultimately to do a lot more customization and make sure things are exactly the way that you want them to be. Hey everyone, it's Max and welcome back. So in this tutorial we're going to learn all about line plots. We're going to continue on with the code that we created last time, but we're going to clean things up a little bit. So we're going to take away some of these axis generations. We're going to stick with just one figure right now, and we'll take that to be the square figure, the figure 2 that we took. We'll also just remove the face color so that we don't have this red outline. And we'll also remove all of these axes generations, so these 9 axes that we generate here through the for loop. And really what we're going to do is we're going to have one simple axis that we put onto this figure, and it's going to take on the full figure size. So we'll just have it be like this. We want it to be one row, one column, and then correspondingly it will be the axis with index 1 and with these index. So previously we learned about the scatter plots, and we'll just take all of this away here too, and we don't need to set the current axes because we've just created the axes here. So all of this we can also just take away. We're just really gonna stick with this baseline of creating the figure and adding a subplot onto this figure, although it's not necessary to do. We'll just leave it in because it's kind of good practice, and it's always good to have this baseline so that we really understand what's going on. Of course, if you want to do this yourself, technically you could just leave these 2 lines out and just use the plt dot commands, but we'll be doing it in reference to the axes, just in case you ever want to make more advanced plots and do more specialization and everything. It's good that you know this syntax too. All right, So yeah, let's go ahead and talk about line plots, or rather let's learn how to make some line plots. And the first thing that we're going to do for this is we're just going to make an X array that's going to just be values between 0 and however many values we have in here, so that we can have each of these points kind of represented as these y values, and then we'll just have x values that go increasingly from 0 to whatever we have here. And so to make that, we're just going to make a quick for loop up here, and we'll define our x variable now to just be an empty list. And we'll make a quick loop here. We'll say for I in range, and we want our x list to be the same size as our home team and our away team goals. So these two are going to be the same size anyway, because home team and away team, you always need two teams playing each other. So these two will be the same size anyway, just by how the data is structured. So we can just say we want it to be as long as the home team goals, and what we're going to do to our x variable is we're just going to append I to it. And so here we're going to get our x is just going to be a list with numbers between 0 and however long this is, -1. So if we want, we can print this out just to see. Just print out this x list here. So yeah, we've got 144 elements in here because we're starting at 0, so 144 different games. But really this is just for plotting purposes, so that our x-axis is going to take on these numbers 0, 1, 2, 3, 4, and so on and so forth. And then our y-axis, we can represent the home team goals and the away team goals. If we want, we can also start at 1 and go to the length +1, and then we can actually say our x-axis is the game number. So the first element, for example, would be the first game, the second element would be the second game, and so on and so forth. So yeah, right, all we're doing here is just creating our x variable. So nothing really too relevant to new commands for plotting. Okay, so now that we have this x variable though, let's go ahead and create our first line graph. And the way that we're going to do that is we're going to go into our axes like this, and we're just going to call the plot command. That's all we need to do. And now we need to put in an x variable, which in this case is the x that we've created here. So this is going to be our x values, and our y values will start off with the home team goals like this. And we can just run it. And so this is what we see here. We've got our x values here, which is just pretty much the game. And then we've got our y values, which are the home team goals, and we see that it's a line plot, so all of these are connected, which may not be the best, because technically they're all individual games, but we're making line plots right now. So each of these games is just connected, so each point is connected to the next point by a line, and so that's exactly what we see right here. So this is the basis, but of course, there's a lot of customization, just like we saw in scatter plots, that we can do with it. So let's get into some of those customizations. So as before, you remember we can always change the color by putting this in here. So you remember maybe that we can type in a color name that we want, red, in which case the line plot would just change to the color red. We can also, if we had more here, we could technically also put in arrays or something. You can also use the shorthand, so B, in this case for blue, the hexadecimal that we've seen like this. We can also add in the hexadecimal we just did, the Rgb values, so again between 0 and 1 here, like such. So yeah, pretty much basically all the colors that we've had before. Remember, since we're dealing with a line plot here, our color is going to be referencing to the line, so we don't want to put an array right now. We just want to put in a single color value because that's the color that the line is going to take on. So yeah, all of that stuff. This is what we also saw in scatter plots that we can do. What we also saw in scatter plots was setting a marker, and so we can do something very similar here. We remember maybe there was the triangle, so if we want, we can put that here, and pretty much every data point is then going to have this, is going to be denoted by this triangle. And so that's what we see here. Every data point is denoted by a triangle. Of course, there are other ones that we can put in. There are many other ones. I'll just show you a couple here. So here we saw the plus symbol. You can also have this vertical line, which you can't really see that well right now. But all of these basically are options that we can put in here. Let's put in something a little bit nicer. So the triangle was very nice and visible. So we'll leave it like this for now. If we want, because these colors are a bit confusing now, so in scatter plots we didn't have the problem of the line constantly cutting through everything. So we also have the option to change the marker face color. So let's just change that to blue rather than trying to explain all about it, but the name is kind of self-explanatory. But if we just change the marker face color to something like blue, we see that the marker's color is changed to blue, and this helps us distinguish things a little bit more. And also, if we want, we can make plots that look a little bit nicer by having complementary colors or whatever. So there's two purposes. One of them is kind of like a visual aid by being able to distinguish things, and the other one is, making the plot a little bit more pretty. So both of those are options that are available to us by this marker face color. And of course, the marker, really helps let us show where our data points are. The marker size is also something that we can control. So we've seen this before in the scatter plot, but there it was just the size. Since we're dealing with this line graph here, this line plot, the size doesn't really make that much sense. There are different sizes that we can change, and we have to reference the exact size that we want to change, or the exact object of which we want to change the size. In this case, we want to change the size of the marker. So if we change it to something like 20, we see the markers get a lot bigger. If we change it to 10, they're smaller, and so you can play around with these sizes too. And so the marker size variable would then change the size of these marker points that we're having here to make it something a little bit smaller, so that's not, that's too small, so that it's not completely in the way. Maybe something like this that's still visible. Okay, so this is all around the markers. What's nice about the line plots is, of course, there's still this line to it, and so this line we can also manipulate if we like. The first thing that we can do is we can change the line style. So right now we're just kind of using a standard full line. Everything is just connected, but this doesn't have to be the case. If we want, we can have something like a dotted line, which we would do using a colon variable, or a colon in here. We could have a dash dotted line like this, a dashed line like that, or we can have the full line, which is the default value, like this, so just fully connected. So there are different line styles too that we can use, which may also be useful if we want to put several line plots on top of each other, and maybe one type you want to have be dashed, and to be able to differentiate them, the other one maybe is going to be dotted, or stuff like that. So that helps for one with visualization, but in a second we'll see that we can actually put several different plots on top of each other into the same axes, and so that's going to also help us differentiate them with these different line styles. And of course, to make it more visible, we can also change the line width. So that would be the other size parameter that we can change. And here again, you can just put in a number. The higher the number, the thicker your line is going to be, and the lower the number, the thinner it is. So we saw for dash, for example, if I make the line, if I make it much thicker, then each dash is actually going to be much thicker. But if I have like just a connected line or something, then, well, yeah, you can kind of see what's going on here. So all of these parameters allow us to adjust both for visibility and making things nice, but also help us, if we have several things in a plot, be able to distinguish them. So to show that, let's also plot the away team goals on the same plot. We can just add it in like this. Maybe we'll have it be a different color. Let's just make it green. Don't want to play too much around with these RGB values. The marker face color, we can have this be black. In this case, let's use maybe a star symbol, and we're going to use two different line styles. So for this one here, we'll use a dashed line, and for this one here, we'll use a dotted line. And let's just keep the line width rather small so they don't completely interfere with each other. So yeah, so this is how we can pretty much just
add several plots together. So you see that if I've created the axes, and until I call this show, really all of this plotting that I'm doing here, and technically if I want, I could also add I could also scatter these variables on here. I'll just take out a lot of these value commands because they don't apply to scatter plots. But if I make this orange, for example, then I can also scatter orange points on here. And so really what's happening is until I show the graph, all these commands that I'm doing on the axes are just going to be superimposed. And so if we're not cleaning it up correctly, things can look quite messy, as we see here. So at some points it's actually really difficult to distinguish the green and the pink lines like we have them here. So maybe something that can make that a little bit better is just reducing the line width. But yeah, so this is how we can go about creating these line plots, as well as the customization that comes along with it. And then of course the other art form that's much more learned is making these graphs look very pretty, and of course choosing the right parameters in each case to make sure that you can distinguish them, but that each of these graphs kind of stands out for themselves. And maybe you don't even want to add markers, so we could just take all of this away. Maybe you just want to keep lines like here. So, and then we can take away the scatter. So maybe we don't want to plot all the markers, and then we can just kind of compare the lines. Of course, here it's a little bit more messy because everything is up and down and there's no real correlation from one game to the next. But if you have data that's a lot more correlated, then these types of analysis may actually be helpful. You know, if you've got some exponential graphs that are going up with different exponential values, or graphs at different slopes, just having these different colors and these different line styles can nicely help you put them all on the same plot, but also differentiate them, and it makes for very nice graphics. Hey everyone, it's Max, and welcome back. So now that we've learned more about the basics of the backend, as well as creating some simple plots like the line and scatter plots and everything, let's go ahead and do some customizations. So the first thing that we're going to look at now is going to be adjusting the x and y limits of our graph. So we can see here, when we actually plot it, these limits are auto-generated for us, but you know, they're kind of okay, but they're not perfect. So we see that we go all the way up to 160, even though we stop at around like 145 or something like that. And the upper y limit is 6, and we actually have points that reach 6. And so just looking at this graph, we're not really sure if the points only go up to 6 or if they go past 6. And so what we're going to do now is just, you know, looking at how we can adjust these different limits. And to show you this on an axis by axis basis, I'm going to split these two graphs up into two different axes. So I'm going to have my axis 1 here, and I'm going to create a second axis, and I'll call it axis 2. And both of these are going to have, so pretty much I'm going to split the figure into two rows. So I'm going to split it in half, one up here, one down here. So my axis 1, my plot 1 will be the first row up here, so it would have index 1, and the second plot will be the one down here, so it will have index 2. And the second plot will just be the away team goals, and the first plot will be the home team goals. So all I had to change was that I'm now plotting the away team goals into axis 2 rather than into axis 1. So let's just save and run this just to see the changes that we made. So we see now up here we've got the home team goals, which we've plotted into axis 1, and down here we've got the away team goals on the same x-axis, just with different y values because the goals are of course different. Okay, so let's go ahead and look at how we can change the x limits first, and then we'll go and looking at changing the y limits. So to change the x limits, we'll go into our axis and we'll use a method called set xlim, like this. And now we can put in here, or we can pretty much define the parameters left and right. So if we want, you know, we can make these equal to specific values, so we can put them in here and say left, which is the left starting point of our x limit. So if we want to start at 0, we can set left equal to 0. If we want to start at x equals -1, so we're doing the x-axis. If we want to start at x equals -1, we can put it at -1. And right is pretty much where we go up to. So let's set it to 145 right now. And we'll only set this for the first axis, so the axis 1, so the one up here. And then we'll look at the difference. So
if we just run this, we see that now we're going slightly below 0, and so we're actually starting at -1, and we're going up to 145. So we don't have any ticks here yet, but it looks like we are going up to 145. And so here we've changed the x limits to be from -1 up to 145, whereas here we're still starting at 0 and we're going up to 160. I actually don't need to put in here left and right. If I just put in -1 and 145, it will assume to be in the order of left and right. So this will give me the exact same result, as we can see here. Something that I can also do is if I want to flip the graph, or if I want to kind of like mirror it along this way, I can say I want to go from 145 to -1. And so what this is going to do is it's going to flip everything for me, as we can see here. So if I scroll up for comparison, we see we've got these two peaks up here, for example, which are bigger, and then we've got the two smaller peaks, so we'll just use this as reference. And we see that the axis was flipped, so now we've got these two smaller peaks down here, and we've got the bigger peaks here. So really, what we've done is we're starting at 145, and we're going backwards down to -1. So if you ever wanted to, flip the x-axis like we did here, and start at the high values and go down to the low, this is the other way that you can do it. You just put in here the values and start at the high and go down to the low. To do this for our lower axis, so for our axis 2, we'll just go into the axis 2 and we can set our x limits, and here we'll just set it to be from 0 to 150, and we can save and run this, and then so we can kind of see the differences, because we're setting different x limits, we see the difference down here where we start and where we end, as well as compared to here. So that's how we go about x limits. Y limits are very, very similar. So if we want to set it for axis 1, we just type in set y lim now, rather than set x lim, and it follows the exact same structure. So if we want, we can do here the left and right, but I'll actually leave these out because usually just put in the numbers because it's easier, and it's kind of inferred that you start with a left and then end with a right, or in this case actually it'd be lower and the upper value. So we can start at 0 if we like, and we can go up to, maybe let's go up to 7 for this one, just to make sure that our points here actually end at 6. And so if we run, we see we start at 0, we go up to the value 7, and we can of course do the same thing for axis 2. Here we can set the y limits, and here again let's go from 0 to 6, just because we end at 5, and that gives, it makes all of this a lot easier to view. If we have a little bit of extra spacing up here, just, it lets us make sure that these points actually end at 5 and they don't go over. Of course, we can also put it to something like 5.5, so these don't have to be integers, as you can see here. So you can play around with it however you like. This is a nice way to adjust the axes, and it's also pretty important to make them more readable, because the difference of this, and if we just take this out, and this, having this extra spacing up here does actually make a big difference, and it is a lot easier to read if you just have that little bit of spacing so that you can see where everything ends. Hey everyone, it's Max and welcome back. So in this tutorial, we're going to look at adding a title as well as some axes labels onto our graph. So what we've done so far is just, added everything in. We've been able to change the x, y limits, change the colors and everything here. Now it's time to do, some more customization. Every graph should have a title as well as axis labels so that it's easy to understand what this graph is trying to tell us. So we'll start with the top axis, and we'll just start with adding a title. So we'll go into our axis 1. To create a title or to set a title, we use the method set title like this. And there are different inputs that we can put in. We can define a label. So really that's just going to be what we're going to label the plot. We actually don't have to put this in. If we want, we can just put in the title directly. So here we can put in, for example, home team goals over the season, something like this. And if we save and run this, then we see that our title appears right up here. We can set it to be equal to the label parameter, so we can define the label parameter like this. But again, we don't need to. We can just put in the title directly, and it will be taken care. It will be taken care of. Let me make this a little bit bigger, and I'm gonna. Actually, we can still see the graph fully, so that's good. I'm just gonna make this a bit bigger though, so that we can see the full code here. Okay, so this is the label that we can add. We can change the location too by defining the location parameter. And here we have to choose between the center, which is the default. So that's what we've got right now, which just puts it right in the center. We can also move it to the left, which will then put it, as you may have guessed, onto the left side. Or we can change the location of our title to be on the right-hand side of our plot, which will then move it over up here. But yeah, let's just stick with the center right now, just because it's nice and symmetric. But yeah, you can always change the location like this, if you want to have a specific formatting or any type of customization. And then there's some kind of free parameters, I guess, that you can choose. So to do this, we need to change this font dict parameter, and really this is like we're going to put in here a dictionary, and inside of this dictionary, inside of this dictionary, there are certain parameters that we can change, pretty much these free parameters. So for example, we can change the font size, maybe make the text a little bit bigger, make the title a little bit bigger, change the font size to be something like 20, which will make the title bigger. We can change the color, so these are kind of the standard colors that we know. We can make the title red if we like, or we can change the title to be blue. So depending on the customization that you want to do to your title, above these kind of very standard things of what the actual title is and where it's located at, all of these parameters can be changed over here in this font dictionary. If we want, we can do the same thing for our axis 2. So we would just change it. Now we're setting the title for axis 2 rather than for axis 1, and we can now call it away team goals. Maybe we'll make it a bit smaller, and we actually won't change the color, so we'll just leave the color black. Yeah, we can leave it blue here if we like. And we see that it puts the title right above the second axis, which is exactly where we said it should go. So this is how we can set the title of our different graphs, as well as customizing them a little bit, and all of that stuff. Now the other important thing, of course, is setting the axis labels. So let's go ahead and do that for our first plot that we see up here. So we'll go into the axis 1. Then we're going to set X label. So this method here is going to allow us to assign a name to this axis down here, which we'll see in a second. So for example, here we can call this the game number, which it technically is. So each of these x-axis points is a different game, and so we'll call this we'll label this x-axis to be the game number. And then it appears right down here. So if you've got many different graphs, you want to make sure that you can distinguish the title from the X label, and so maybe working with spacing is something a little bit more important here, but right now we kind of know what everything is referring to. So we've got this X label here, which labels the X-axis and shows that it's the game number. Also here, there are other parameters that we can define. So one of the things is actually something called a label pad, which is just a spacing between the X-axis and the label. So we can put in something like 5, which would put, well, can't really see it right now. Maybe let's try something with 15, just make the spacing a little bit bigger. So we can see the spacing increases between the X-axis and the label. We can make it something smaller, like 10. So depending on, if you change the font size or anything like that, or if things are too clumped here and you actually want to make the spacing very tight, you can maybe pull it a bit closer. But depending on what you need, you can move your label away or closer to. Maybe there's some weird overlap, or the structure just doesn't look nice and you want that extra spacing to make it look a little bit better. All of that you can do in here in this label pad. And just like we had before for the title, we can also define this font dict parameter. So this font dictionary, which as the name suggests is a dictionary that just has these parameters for the font that we can change. Something that we can also do that's pretty cool, something called a rotation, which, as you may have guessed, just rotates the label. So if we put a rotation of 45 degrees, it's going to rotate it by 45 degrees counterclockwise. So that's what we can see right here. Of course, this isn't perfect because our label is way too long and it kind of goes down to this other graph. But depending on what you have, maybe you only have one big plot. Maybe if we take all of this away, and let's see, where else did I put? And we'll take this away here so that we have this one big plot. Now we can see, so there's no overlap anymore, and we have this nice rotated label in case maybe things look better like this. So there are a lot of free parameters that we can change in this font dictionary, and of course these aren't the only ones. So if there's something specific you're looking for, chances are you can probably do it. But yeah, it's important to know that all of these changes can be done, and you would just have to change the parameter inside of this font dictionary. All right, and we've done this for axis 1. We can literally do the same thing for axis 2 if you want, by just copy pasting this down here. Same format, we'll just put it on axis 2 in this case rather than on axis 1. Here I'll actually put the rotation, and I'll take it away up top so that we don't overlap with the title. And let's run this. Oh, did I? No, it should be okay. There we go. Okay, so here we've got this kind of flat game number, and here we've got it rotated just like we told it here. And finally, we want to change the Y label, so we can, first we'll go into our axis 1, and we'll set the Y label like this. So this method pretty much does the exact same thing as this X label, except that we can now change this Y label that we have right here. So for axis 1, it will be home team goals. That's what the goals like this. That's what the Y-axis represents. And for our second axis, it will be the away team goals like this. And so we see the rotation is actually such that we have it now vertical rather than the horizontal default that we have here. For X-axis, our Y-axis has this vertical default. But just like we were able to do for this set X label, all of these parameters here, so this label pad, these font dictionaries, all of those are still valid for this set Y label too. So the only difference really is this X and Y label, depending on where we want to put the label, but all the parameters that we can change in here are just as valid for the setting of the Y label as they are for the setting of the X label. Hey everyone, and welcome back. It's Max, and before we move on, I want to show you some cool things that we can do with the text. So last time we looked at adding titles and X and Y labels and stuff. And something that's pretty cool is that we can also add a kind of math formatted text here. So we'll just do that to the title just to show as an example. And the way that we can add this math formatting is first we have to put an R in front of our string, and that's going to effectively make it a raw string. So we can see the R actually gets color coded if it's in front of these string parentheses. And inside here, now we can use LaTeX code. So if you're familiar with LaTeX, it's a program that is very often used to kind of write up scientific reports or write math equations or all of this stuff. Yeah, so we can use this LaTeX-like code and use that here in Python to add some math formatting. So for example, if I wanted to put in a fraction up here or anywhere, then to do that, first I need to enter the math environment, and I need to close it at the end. So to enter the math environment, I put this dollar symbol here, and then I put another one to end it. And now inside here, I can write my math equation. So for example, to put in a fraction, I'll do the \frac, and then open and close for the numerator, and open and close for the denominator. So for a fraction of 1/2, for example, I'll put in here \frac12, which if we put this into a LaTeX editor, this will give us a 1/2 fraction. And so if we run this, we can see up here, this is the formatting that we would get from it. So we can actually make fractions and all of that stuff too. So that's something pretty cool that we can do with all this text here. And of course, we can also put it in other locations. So if you're familiar with LaTeX, then, and if you want to kind of incorporate all of these things, then this is the way to do it. For example, like an exponential, we can say like e, maybe we want to do e to the power of 1/2 or something like that. So all of this type of math formatting is very nice. It's a very nice way that we can kind of enter it here. So the only thing that we need to do is just put this r in front of the string, which will make this into a raw string, and then we need to enter our math environment, and we can also use other parameters like lambda. So pretty much all of the stuff that we have access to in LaTeX, we can now put in and use in our Matplotlib environment too, for plotting and especially for changing the text here. Hey everyone, it's Max and welcome back. So the next thing that I want to look at is adding as well as formatting major and minor axes ticks. So right now if we run our plot and we see it, then here we've got a major tick every 20, which can make it a little bit harder to read. Let me just move this over a little bit so that we can see everything. So what would be nice if we can change where these ticks appear, as well as maybe adding in some minor ticks so that we can differentiate each of the events. All right, so to do this and to make it a little bit nicer and easier to see, I'm actually just going to remove all of the axis 2 stuff like this. So everything that we'll do on axis 1 will of course be valid on axis 2. We would just have to change the axis that we're applying it to, as well as any other axis. So I hope you're starting to see that if we want to do a specific axis, we just have to put the axis name up here. So we've created our axis 1 here as a subplot to our figure 2, and all of that stuff we're doing into this subplot, into this axis here. So to do any change to a specific axis, all we really need to do is just go into the specific axis and apply the command or apply the method of whatever it is we want to do. I'm just taking it away so that the whole screen doesn't look as cluttered by having two different graphs here. All right, so let's go ahead and change these ticks up a little bit, and I'm actually gonna flip things around a little bit again. So I'll make it go from 0 to 145 so that everything is nice and ordered now. So to get in all of these ticks, we're actually gonna scroll to the very top, and we're gonna need to import some of the tick stuff specifically. So we're gonna go from Matplotlib, but now rather than going into .pyplot, we're gonna go into .ticker. So this is where we can find some of the extra stuff that we can use to manipulate these ticks. We're going to import something called a multiple locator, as well as a format. Actually, maybe I'll put this over 2 different lines so that we can see both of them nicely. Format, string, formatter. So these are the 2 things that we're going to import. We'll see in a second exactly what they do. Of course, you can just put this here separated by commas onto the same line. The only reason I'm not doing this is so that we can see them up here, so that it's all nice and visible. Okay, so let's go ahead and see what these things can do for us. We'll start applying them down here. So the first thing that we're going to use is going to be this multiple locator. And what the multiple locator is going to allow us to do is it's going to pretty much, we're going to say every X number of ticks, this is where we want to have a tick. So it's going to find this X number, which it sounds a little bit strange, but let's just see it through example, and then I'm sure you'll immediately understand what this multiple locator does. So let's have these major ticks occur every 10 rather than every 20. So we want our major location, or maybe we'll call it the major tick location, to be equal to, and then we'll use our multiple locator, and we want to locate every 10th tick. And so to apply this, we'll go into our axis 1, and here we're actually now we're gonna have to choose the axis that we want. So for example, if we want to apply this to the x-axis, which in this case we do, because we don't want to have the y-axis only have a major tick every 10, because here our data is much more granular, so we've got much more every point, whereas here our data is very granular to here, but the range is much bigger. So we're going from 0 up to 145 rather than between 0 and 6. So we're going to choose to apply this only to our x-axis, and here we're going to say set major locator as we've used this multiple locator here. And we're going to put in here this major tick location. So let's go over again. I'll run this, and then let's go over again just exactly, what did we do here. But let's see it in effect first. So immediately we see now we don't have ticks every 20, but we've got ticks every 10, and they're also labeled. So that's nice. That makes reading this a little bit easier because, well, technically our domain is bigger. Our domain is going from 0 up to 145, so it's easier for us to kind of differentiate these things. So what's going on? Well, what we set here, our major tick location, is we use this multiple locator method that pretty much what this does is it allows us, it finds every 10th tick. So it finds the location of every 10th tick, and then we can use this, and because now we've set the major locator, so what we're doing here is we're setting the major locator, and we're doing this on the x-axis. And we're setting the major locator, so the location of every major tick, to be whatever this value is that we put here, and this value is every 10th tick. So here we can change the tick number. So for example, if we want to have it every 20 ticks, if we want to have a major tick every 20, like we had before, we can put in 20. If we want to have it every 50, we can put in 50 here. If we want to have it every 5, we put in 5. And so really what this does is just kind of identifies every 5th major, or every time we go kind of 1, 2, 3, 4, 5. And accordingly, it will then put a tick there for us. And so this x-axis thing, so really we're going into our plot. More specifically, we're going into the x-axis. So rather than, just what we had here, set the x label or set the y label, we've actually gone into the axis directly now, and we've set the major locator of the specific axis. So we've set the location of, the major axis ticks to be at every 10th value. So that's what we've been doing here. All right, so we can do the same thing for the minor ticks. We actually don't have any minor ticks right now, so we'll introduce those. We'll have our minor tick locations, and we'll use the multiple locator. I'm just going to copy paste this because it's weird to spell. And we want to have a minor tick every 5. And so in a second, we'll see what minor ticks are. And we'll go into our axis 1. Again, we want to do this onto the x-axis. And here we want to set the minor locator to be wherever our minor tick locations, wherever we want our minor tick locations to be, so every 5. So if we run this, we see that these are the minor ticks. So we've got this small kind of tick, and they don't have a label. Maybe if I do it more frequently, so every 2, maybe we can see things a little bit better. But we can see there have been little ticks added in here. So now we can, break down things even better, and we can see, these are the 10 points, but we can also use closer references to now it's going to be in steps of 2. So 2, 4, 6, 8, 10. We've got another 2, 4, 6, 8, 10. So that's how we can set these major and minor ticks. We can actually do the same thing. So if we want to do this for the y-axis, we would just change the x here to the y. We just want to make sure that we would change these values. So maybe here we would do something like 0.5. And then here we can add a minor tick every 0.5. Now for the y-axis, it's really not that applicable because our y-axis is going to be whole numbers, as are the values here, but this domain is a lot bigger. So we're going from 0 up to 144, and so it's going to be useful to have a tick maybe every 5 just to kind of show the midpoint. Whereas here, we're already resolving every number, so it doesn't really make sense to have a tick in between because we can't have a goal scored of 4.5 in soccer anyway. So yeah, so it makes more sense for the x-axis, but of course you can do the same thing for the y-axis, and I'll put this here as a comment by just putting a y here. And maybe you also want to change this so you can have you can copy this here and call this like maybe like a y minor locator of 0.5, and this is where your y minor tick locations are going to be. So just for reference, I'll put this in here. In this example, it's not that applicable, but maybe generally it is more applicable. Okay, so the last thing that I want to do is add some string formatting. So this is optional, we don't need to do this. This is going to be changing our label ticks here. But yeah, let's just do it anyway. So we'll change the major tick format. And for this, we're going to use the format string formatter. And what we can put in here is we can put in a Python string format. So this is something, if you're not familiar with Python string format, I won't really go into much detail with it, but you can use this to format how you want numbers to look in a string, or you can use this to format strings, and so there are specific kind of commands that you can put in here. So for example, one thing that I'm going to do is I'm going to use %03D, and what this is going to do, we'll see in a second what this does, and I'll explain it again in a second, but let's just put in the formatting first. So to do that, we'll go into our axes, into our x-axis, we'll set the major formatter in this time, so we're not doing the locator, we're doing the formatting, so we'll just set the major formatter, that's what this method is going to be called, and yeah, it's going to be the major tick format. So if I run this, then we'll see that basically what I've done is I've said everything is going to be, has to take up 3 spaces, and that's what we're doing here. And for those things that don't take up 3 spaces, I'm going to add leading zeros. So that's what we're doing here. We start off with 0, but we want everything to have the same number of digits, the same number of places. So in this case, 0 would be 0, 0, 0, 10 would be 0, 10, 20 would be 0, 20, and so on. Once we reach 100, we have 3 digits, so then we don't add any leading zeros because we already have 3 spaces taken up. So yeah, if you're familiar with string formatting, and if you want specific formats for your ticks here, this is the way that you would add it in. And of course, you can do this to the y-axis too. So we can go into our, actually let's just copy this because this is a lot to write. Go into our axis 1, and here we'll do the y-axis, and we're going to change the y major tick format, and in this case, let's have it be 2 decimal places rather than 3. And so if we save this, then we see that, oh, I forgot to put this name in here. So we're going to, for the y-axis, we want to use the y major tick format. And so we see now all of our numbers here take up 2 places. So we've got a leading 0, which will disappear if we reach 10. So then it would just be like 100 when we reached it. So there would be no leading zeros anymore. But yeah, so this is how we can add, or how we can change the string format of our labels. Hey everyone, it's Max, and welcome back. So while we're still on the topic of ticks, the next thing that I'd like to show you guys is how we can modify all of these ticks that we have here. So right now it's just kind of taking on default values of numbers as we see right here, but maybe we want to change the ticks to be something completely different. So that's what we're going to look at now, is how do we modify all of these ticks. And to do this, first of all, I'm going to take away this major tick formatting. It's not really going to interfere that much, but it's not really necessary anymore. So we can still set the major and minor tick locations, which is fine. But we don't really need to set this formatting anymore if we want to change all of our ticks anyway. Or if we want to change some of our ticks, then we can still leave this formatting in. But yeah, anyway, so to do this, we're actually going to go after we've set these major and minor locations, as well as maybe some of the formatting that we've done. And we're going to first need to get all of these ticks. So we're going to save this in a variable that we're going to call xtick labels. And we're going to go into our axis 1, and we're going to call a method called get xticks, like this. And so this is just going to get all of these xticks here for us. And we're actually going to go into this and say we want to go and cast this to a list. So this is, nope, there's no underscore here. This is actually one of those special methods that we can use on the response that we have here. And just to see what we actually get, let's print out these xtick labels to understand what's really going on. So what we're getting is we're getting these axis tick labels, and we start at -10 and we go up to 150. And these are the labels that are going in here that are going to label our axes. So we see that the 0 goes to here, the 10 goes to there, 20, 30, and so on. So we're getting all of these x tick labels, and we've converted them to a list, which just makes it easier for us to change in a second. So that's exactly what we're going to do now. Let's just go ahead and go into our x tick labels, and we're going to change the third element, so this one here, which is going to have index 2, and rather than having it be the number 10, let's just change it to the word 10. So what we've done is we've gotten all of the tick labels from our axis, we've saved them into a list, we've then updated this list, and now we just need to update the ticks, so kind of reset the ticks. And to do that, we're going to go into our axis that we want to change, and we're just going to call a method called setXTickLabels. And in here, we're going to put the array of the new labels that we want our axis ticks to have. And so if we save and run this, we see here now that the number 10 has actually been replaced by this string 10. And what we also see is before we actually had integers, but this method actually converted everything to a float, so now we have floating numbers here. So we've got 20, 30.0, 40.0, all this stuff, rather than having it be in integers. So, to change this, either we could go in here and say, like, we want 3 to be 20 rather than 20.0. So these are ways of changing some things manually. Or we could use a little loop in here and say for t in this, and we want to convert this to the integer version of it. So this is a nice little loop that we can write that actually creates a new array for us, and it goes through this old list. So it's a for loop going through this old list, and it takes on each of these values, and the values in our new array is going to be the integer version in this case of this t. So really what we're doing here is we're having a shorthand for the following for t. So then we're doing this for loop here, like this, and then we're appending the integer version of t. So all of this here, this is actually a shorthand for it. So this and this will give us the exact same result. This is just a shorthand version for it. So if you haven't seen it before, it's kind of nice to know because it cuts out 2 lines of code, and it's also a little bit easier to write. So this is some kind of cool trick that we can do with Python. But yeah, this and this will give you the same, or sorry, this and this here will give you the same result, just in case you haven't seen it before. So if we save, and actually we can comment this out. So this will allow us to keep everything in its integer version as we see here, and then we were able to update individual elements like this. Of course, we don't even have to use the same ticks. We can actually change them completely. So we can put in here our own list if we want. We can do, say, test1, test2, and test3 just to see what happens. So we can put these in, and the first value, if we scroll up, was actually at -10. So this one doesn't appear, and then it pretty much gets filled in until we run out of elements here in this list. So in this case, we go from -10 to 0 to 10, and afterwards we didn't add any more labels, so everything else is blank. So these are different ways that you can kind of modify the ticks. You can use the ones that you already have and just change some individual ones like we did here, or you can just put in your completely new labels and just change all of them directly. If you want to leave out some blank spaces, you can also just put in empty strings, which will push things over a little bit. So if you want to have like a start and then, I don't know, some blanks like this, and then you want to have like a middle, and later on you want to have like an end. So these are all of those things that you can do too. Yeah, you can really get creative with it, but yeah, this is the way that you would change it. So you would go into your axis, you would set the xtick labels, and then you would put in the corresponding list that you want. There's another way that we can do this, which sometimes may be easier rather than having to use the axis, is if we have the axis already set as the current axis. So if you remember, we can go into plt.sca to set the current axis, and we want to set this to axis 1 in case we have multiple axes that we want to deal with. We can also just go into matplotlib.pyplot and call xticks, and then we can put in here an array of ticks. So we can have this be like 1, 2, 3, and this will actually have the same effect as this. Sorry, let's see what's going on here. Oh yes, we need to put in also the ticks that we want to replace. So in this case, let's replace 10, 20, and 30 with 1, 2, 3, which will give us this result here. So this is where 10 used to be, this is where 20 used to be, this is where 30 used to be, and it's replaced with 1, 2, 3. This doesn't have to be in order, so like we can do like 10, 20, 1, 40, or I mean, you can go like this. So yeah, we can change things around like this. So this is another way that you can set X ticks, which may be a little bit easier to do at some points. But of course, this one will eventually allow more customization, and it also doesn't require you to set the current axis. You would just set the X ticks in whatever axis that you're calling this on, like this. All right, so these are two ways that you can change the tick labels, like we have them here. And I'm going to comment this out for now because I want to show you another cool thing, which is if we just run this, so we get back to our kind of old values here, we actually took away the formatting too. I want to show you how you can rotate these things too, which may be useful, especially if you have like longer ticks here and they start overlapping. At some points, maybe you want to rotate them a little bit. So we'll see how we can do that now. We're going to use a for loop for that, and we'll just call each element here an X tick, which is exactly what it's going to be. And to get all of these X ticks, we're going to go into our axes, whichever one that we are using right now, and we're going to call a method called get X major tick labels like this. And so what this is going to do is it's going to give us each of these tick labels as a kind of individual element that we can now use. And so each of these has their own methods that we can apply to it. And so here, for example, we can set the rotation to be 45 degrees, so we'll rotate it 45 degrees counterclockwise. And rather than talking a lot about it, let's just see what it does. So what we're doing here is we're getting each of these ticks, each of these X major ticks, one by one. And to each of these ticks, we're giving it a new rotation, which is what we see here. What we can also do is we can have like a little counter like I, and we can increment I by 1 every time. And we can set the rotation to be I, and so we'll slowly have like an increasing rotation. Or maybe we'll increase it by 2 every time. So you can see that we're getting a slowly increasing rotation. So with this, this allows us to have a lot more customization because we can really change each of the individual ticks rather than doing everything at once, which we can do if we use this again. Here there's actually a rotation. We'll put this on a new line. There's a rotation parameter that we can define like this. But as you can see, this is very nice for doing like quick substitutions and stuff, but this here actually allows for a lot more customization. So depending on what you want to do, maybe you just want to do it, you want it all the same, you want to do a quick replacement, in which case you would do this. Otherwise, if you want to do, change individual ticks, then you can go about it like this. So depending on, like how much detail you want to go into and how important it is to, do special formatting, you can either use the easy way, or this one here with this, depending on, what you prefer, or what may be more appropriate. Or you can use the ways that are a little bit more complicated, but that allow you to do a lot more specialized customization. Hey everyone, it's Max, and welcome back. So what we've seen so far is we've done a lot with the titles and labels, and we've also looked at ticks a little bit. I've taken a lot of this stuff out because it's started to clutter the code, and it's not really necessary, especially replacing the ticks and everything. So I've kind of gone back to more of a default plot. And the next thing that I want to show you guys is how we can add a legend to our plot. So before I do that, I'm actually going to make this just a little bit smaller so that everything fits onto one screen a bit more nicely, and then let's move this back over like such. Okay, great. So let's go ahead and add a legend. So a legend, if you don't know, is just something that we can put in the plot that will have some information about the different things that we're graphing here. And the way that we add our legend is whenever we're plotting something, so in this case it would be a line plot, but even if we did a scatter plot here or anything like that, we have the option to add in here or to define a label parameter like this. And we just make the label equal to something, and this is what we're going to call it. So in this case, maybe we can label this HTG for home team goals. So now we've added a label. So if we do decide to create a legend, this dashed pink line would be labeled HTG, which stands for home team goals in our case, but of course you could call it something much longer. I just want to keep it short so that the legend doesn't take up half of our plot. But if I save and run this right now, nothing's going to pop up. That's because I still need to apply the legend to the plot. And to do that, I'm going to go into our axes here, and I'm going to type .legend, or I'm going to call .legend, and basically this is all I need to do. And if I save and run this, now we can see that I've added, that it kind of automatically adds this legend here, and it adds it in the top right corner. There are some cases where that may not be the best position, especially if you have some graphs that kind of go up and the legend will cover a lot of it. So you can choose the location where you want to put it in by just defining this lock parameter. And basically there are a bunch of different things, but the things that we need to know is that there's upper and lower, there's left and right, and then there's center. So I'm going to write these here. There's upper, lower, left, right, and center. And actually I'm going to put center here because the order makes a little bit more sense like this. So upper or lower is always going to come first. So we can do, for example, upper, and then we need to combine it with something else. So like upper left in this instance, which would put the legend up here in the upper left. We can also do upper right, like this, and which would put it up there, or we can do upper center, which would put it up here in the middle. So upper and lower are always going to come first, and of course if we do lower, we can do the same thing, center, left, right. I'll just run it once for lower so that you can see what happens, but I'm not going to run it for these other two. So upper and lower will always come first if we want to use it. We can also put in here center left, for example, or we can put in here center right. So center can either be left or right, depending on if we want to have, left or right in here, or if we want to use upper lower. So yeah, well, we saw that before, this upper center. So depending on, if we're using upper and lower, or if we want to define left and right, the position of center as being the first or second term changes accordingly. And then we can of course have these things by themselves. Well, we can have these three things by themselves. So we can have center, we can have left, which actually doesn't do anything here. So I guess we can't have left, but we can have right. So here we can see pretty much all the terms that we can have. So we can have it right here. And then there's also this option called best, which should give you the best position, but if you have a more complicated fit, so I can put this maybe on the next line. If you have more complicated graphs, you probably want to put it into your own position anyway, because maybe something will be covered and you can adjust it all accordingly. So that's how we can go about setting the location of this legend. If we have several plots, which we probably will most of the time, so let's put in here another plot. In this case, we'll plot the away team goals, and we'll change all of this. We'll make this a dotted line, and the label is going to be away team goals, and the color is going to be something different now. Basically, all we needed to do was just add the label here in our second plot. The legend would just, the legend defines this legend here, and actually this is a really terrible color to use because we can't see anything. So let's try something else. All right, let's just do blue to make sure that we can see this. So we see that we've got this blue dotted line here for the legend, which also pops up here. The fit in this case is best. It works fine, and we've applied this legend to the axis 1 where we've plotted everything into. So if we were to have a second axis here, like we sometimes did in some of our previous examples, and we'll make this one 2, 1, 2, and we can make this one 2, 1, 1. If we put the legend onto the wrong axis, then it's not going to show up for us. So you want to make sure that we actually put the legend where we want the axis to be. And also, if we call the legend too early, before we added the rest of our plots, then they shouldn't be included in our legend either. So you want to make sure that you call the legend only after you've created all the plots that should be part of it, and you want to make sure you put it into the right plot. Hey everyone, it's Max, and welcome back. So now that we've looked at legends and all this stuff, I've taken out some of this code again, just so that we have this one basic graphic, pretty much with the chart here, because we really don't need much else, and everything else is just kind of clutter right now. So I've left some of the stuff in here as well as the comments, but I've reduced us just to having, one subplot again, and I've taken out the away team goals that kind of overlapped here because everything was just cluttered. Because now the thing that I want to look into is adding text annotations onto our chart. So it could be that, maybe not here, but maybe in other plots. So maybe if we look at bar plots later or something, you want to add text annotations somewhere. You want to put text directly onto the graph rather than just having a title or X and Y labels. Or we also saw how we could change the text of these ticks here. Rather than doing any of that stuff, we just want to add text directly in. So that's what we're going to look at now. How do we annotate our graph, pretty much? All right, so first thing that we're going to do, of course, is we're going to go into our subplot. And to start text annotation, we're going to just call a method or use a method called text. Now, the first two input variables are going to be the X and Y coordinates. And of course, you can say like X equals and Y equals like this. So I'll also just put this in here. We'll have the X and Y. And this just corresponds to the X and Y coordinates on your graph here. So let's say I want to put my text here at 40 on the X scale. So I'll just put in here 40. And at 4 on the Y scale, so just right up here, I'll put 4. And then I just need to put in my text. So technically, you would define the S for string, I assume. So you would just define this character here, or this value, or this variable rather, and just put in whatever text you want to have. So here, for example, we can just put in the test text just to see if it works, and then we can save and run this, and here we go. We've got our test text up here that's sent, or that's starting here with the bottom left at 40 and 4. Now, of course, these variables aren't actually necessary. These are kind of assumed. If you just put them in this order, it's going to assume X, Y, and the text. So this will work just as well, and it's usually a little bit easier to do. You just have to remember the order. That's going to be X, Y, and then the text. But yeah, that's kind of the basics of how we add this text. Now, with this text, along with all the other text that we've seen, so the other text would be these X, Y labels, the title. If we change these axes ticks, if we change their name, there's always a lot of customization that we can do, and it's important to remember actually, or it's important to know actually, that the customization that we can do to all of these texts, they're pretty much identical. So if I can change the font color of some text somewhere, everything that's text, I should be able to change the font color of, I should be able to change the font size. So texts are kind of like these objects that have the same properties. And so it doesn't really matter if I do like a text annotation or something, or if I have my title somewhere. Where did I put my title? Right here. So if I have my title, or the X and Y labels, these text, all of them have these properties that I can change. So we've seen some of them. I'll go over some of the ones that we've seen just to kind of show you, but I'll first want to introduce some new ones that are kind of specific to this text annotation right now. Because what we can see here is that the text, it's kind of anchored is what it's called. The bottom left corner is anchored to this 40 and 4 coordinate. But maybe we don't want to have the bottom left corner start here, and then maybe rather than trying to say or trying to guess like let's see if I put 35 here or something that I can get the center in there, rather than trying to play with all those numbers and trying to get this perfectly centrally aligned, we can just change the horizontal alignment is what it's called. Now it's a long word, so if I have a typo in here, I'm sorry, but let's just hope that there's no typo. But yeah, the horizontal alignment is going to be where this
where this text pretty much starts. So for example, if I change it to center, I want you to know here right now it's anchored to the 40 and 4 in the bottom left corner. Now if I change this horizontal alignment to center, the anchor is actually at the center of the text. So we see now it's nicely centered at 40 and 4. So we've got the bottom side and the center, that's kind of our anchor point, and that's where the text is going over. Similarly, I can also change the vertical alignment, which is the same thing that we did here, but rather than going left to right, we can go up and down. And so here, for example, I can also put in center. There are other things, and I'll show that in a second. In this case, we're going to have the center point be at 40 and 4. So now, before, if you remember, we had this bottom left point being over here at 40 and 4. But now we've changed the alignment so that the center of the text is actually at 40 and 4. So these are these nice kind of aesthetical things that we can put in. Yeah, so there are of course other things. So we can do horizontal is going to be this kind of horizontal movement. So we can do left, we can do right, and we can do center. So left is what we had before. That would be the left side here anchored. Right would be this right end of the text, like we see here. And center is what we just had. So we've got that center point here at 40. And for vertical, so actually let me copy paste this up here so we have some space. For vertical, and actually I'm going to make this graph a little bit smaller so that everything fits on the same. There we go. Okay, so for vertical alignment, we can do bottom. Oh, take out these quotation marks because I didn't use them before. We can do top, and we can also do center. So bottom is also what we started out with. That's the bottom of this text is then going to be on this height of 4. Top is going to be the opposite, which is going to be the top of this text is going to be aligned here at 4. And center we've already seen, which is just going to be the center of this text is going to be here at this 4 mark. So this is one of those cool things, you know, for alignment that you probably will use a lot because it's not often that nice to have the bottom left box anchored. Sometimes it's much nicer to have it be like centered and centered or something like that. So this alignment thing is actually quite nice, and especially if you want to do text annotation, you want to make sure that the text is in the right position, or else it just looks weird and a little strange. Okay, so some other things that I wanted to show you is, of course, just to show you that it does work like anything else. We can also add this rotation, just like we had before. Now, the rotation actually goes about the anchor point. So in this case, we've anchored it at 40 and 4. So we see that we're rotating about here. Now, if we were to do the bottom left as our anchor point, we see that we would just kind of be rotating about this 40 and 4 point over here. So that's also something important to note, but we'll just leave it at the center. Yeah, but this rotation is something that we also saw once for these X labels, as well as for these ticks that we had here. So we were able to set the rotation. And this is again just because everything here is text, and so they all have these properties that we can change. And there are of course other things like the font size, the face color. All of these things are text properties that we can change. I won't go too much into them, or actually I won't go into them here because we've already looked at them. There's one more thing that I want to show you, which is, or actually there's two more things. One of them is a style. So this would just basically be adding italics, which you actually can't see that well with a rotation, so I'm going to take that out. But here we see I've added italics. I can also do something called oblique, which I think is just more extreme italics, but I'm not exactly sure. I can't really see that much of a difference. But these are different styles, and then of course there's a normal style, which is the default one. But basically I'll just put in here italic, because if you want to use the normal style, that's kind of the default one, so you don't really need to define that. And oblique and italic really doesn't look any different to me. Okay, and finally, the last thing I want to show you is the weight. And now this corresponds to pretty much bolding something. So there are different ways that we can do this. One of them is going to be a range of numbers that we can put in between 0 and 1,000. So for example, if I put in 500, well, doesn't really look like anything to me. Let's try 1,000. There we go. So this is a bit more bold. So you can, change how bold this is, change the kind of weight of the text is what it's called, based on what number you can put in here. Otherwise, you can also actually put in words, and I'll just show you one of them. One of them is called bold, so you can just do kind of the standard bold. And now there are different things in here. I think there's like extra bold or heavy bold or stuff like that. So if you want to use these words, then these would also go in here, but I don't actually remember all of them. But yeah, just know that you can put in here these numbers between 0 and 1,000, as well as words like bold, and then there's like light bold, heavy bold, or extra bold, or something like that. But all of these are documented, so I'm just pretty much showing you all of the things that you will probably use. And if you want to use any special extra things, you can just look up, like how do I make the text this kind of bold? And the answer will probably appear either right in the documentation or on some kind of forum. But yeah, it's important to know that all of these are options that are available to you. And also remember again that because all of this is text, this is text, this is text. So like if you're using text, you shouldn't think of these things as different text. You shouldn't really think of a title and this text annotation here being different, because the changes that you can make to this text are similar. So like for everything I can change the font color, the font size, all of these things, the boldness, rotation, italics probably, all of these things should all be doable across different texts. So that's the other kind of important message that I wanted to bring across in this lecture, is that text is text. And of course we can go through all of the maybe 30, 40 different customizations here, but it doesn't really make that much sense because you probably won't use most of them. The most important ones are probably these X and Y coordinates, the text here, and the alignment. Most people wouldn't even use, like I barely even use adding style or weight. Maybe changing the font size or adding some color, but usually I just kind of go with the standard settings and just put it where I want it, put in the text, and make sure that it's aligned correctly. Hey everyone, it's Max and welcome back. In this tutorial, we're going to look at how we can change the visibility of these spines here, as well as the ticks associated with them. So right now, if we look at our plot, we see our graph is pretty much surrounded by this block. Now this block is made out of 4 lines. We've got this bottom one, this right, this top, and this left one. And these lines are actually called the spines of our axis. So we'll go into our axis and we'll see how we can turn off each of these individual spines, as well as how we can get rid of the ticks in them, so that we have this nice graph, and maybe we only want to have like the left and the bottom one, or maybe only the bottom, or whatever else we want. All of that we can do by turning on and off these spines, as well as the ticks associated with them. All right, so let's go get started with the spine. We'll go into our axis, so we'll go into our subplot, which we saved as axis 1. Now we're going to go into the part of it that's called spines. So similarly, when we went into the x-axis, for example, before when we looked at ticks and all of those things, now we're going to go into these spines, which gives us access to these properties. The only thing that we need to do now is actually select the spine that we want to use. So kind of like a dictionary here, we want to select the spine that we want to use, and our options are bottom, which would be this one here, then we've got right, which is this one here, then we've got top, which is the one up here, and we've also got left, which is the one up here. So let's just start with removing the right spine. So we'll go into the right spine, and then we're just going to go access this property, or rather call this method called setVisible, which just allows us to change the visibility. So right now the value is set to true, which as we can see here nothing happens. But if I set the visibility of this right spine to false and I run this, we see here the spine disappears. Now the ticks are still here, so we're going to need to get rid of these in another way, and there are different ways that we can do it. So the first way that we can do it is if we want to have ticks on our left side, so we want to keep our axis ticks, we just don't want them on the right side, we only want them on the left side, then the way that we can do that is we can go into, well, first we would go into our subplot, then we would actually go into our y-axis, so just because we wanted to control the ticks of the y-axis, and these ticks, this is where they're going to be located in. So to get access to these ticks, we're actually going to need to go into the y-axis rather than the spines. That's just kind of the way that Matplotlib is set up. Then we're going to call a method called setTickPosition, like this. And now the well, the values that I can put in here are either going to be left, are basically just going to be left or right, like this. And so it's going to allow me to choose where I want my ticks to be. So for example, if I want my ticks to only be on this axis, then I'm going to put in here, set the tick position to left. And if I run this, set tick position, did I have a typo here? Oh, yeah, set ticks position, my bad, this is a ticks plural. So rather than set tick position, we've got set ticks position. Now if we run this, there we go. So we've had the ticks that we've had before. Now they're only visible on the left side. We could, of course, also just put them on the right. And now we see that all of these ticks are going to be appearing here, as well as the corresponding, well, tick numbers. And we don't actually have any on the left side here. So that's one of the ways that we can change these ticks. If you want to get rid of the ticks completely, there's a way that we can do that. And we can go into our axes, and we'll go into the y-axis. And now we can set the ticks to pretty much an empty list, like this. And that's just going to get rid of all of the ticks for us. So it's going to get rid of the right ticks, and it's also going to get rid of the left ticks for us. If we completely want to remove the y-axis, we can also do that. We can go into axis 1, y-axis, and then here we can also just set visible, the method that we used before on our spines, we can also use on the y-axis. We can set this to false. And that will pretty much remove everything associated with this y-axis, except for the spines, of course, because the spines are a different property, not controlled in the y-axis, but the spines are controlled in the spine subsection. We see we've got the label that disappeared, we've got the ticks that disappeared. The ticks actually disappeared from both sides. So if I take this away, we see we've got our tick values coming back, our y label, we've got the ticks on both sides. And so if I set the visibility of the y-axis to false, it's going to take all of that away. So those are the different ways that we can change the visibility of the ticks. I'll just put it on the left side now, because what I'm going to do is I'm also going to remove this top part here, so that we just have this open graph with ticks down here and ticks up here. But of course, you can just change all these around, and X and Y are always going to be interchangeable. So anything that I can do on the Y-axis here, I can just replace all of this by X and do it on the X-axis instead. So that's just kind of an important side note. Of course, also we can do that here and here. All right, so let's continue on and let's remove these spines up here. So we'll go into our axis 1, we'll go into the spines. Now the spine that we want to remove is the top one up here. So that's the spine that we're going to go into, and we're just going to use the method setVisible to set the visibility of that spine to false, and save and run. So we've gotten rid of the spines up here. Now we just want to move, or now we just want to say that we only want the ticks down here. So we're going to our axis 1. This time we'll go into our x-axis, because the top one and the bottom one here, these correspond to our x-axis. And here we're going to set the ticks with an S, position to bottom. And so we have the option here of top or bottom. So the names here, you'll notice, are they can pretty much carry over. So the spines that we select are bottom, right, top, and left, and similarly, the same values are used here in the set tick positions. You'll notice they're also going to be used in other parts too. So there's left, right, top, and bottom. They're pretty much kind of the way that you define, or the way that you kind of reference if it's like up or down, or left or right. So those are the words that you're going to be using. And so if we save and run this, now we've set the x-axis tick positions to only be at the bottom, and we see that our graph is kind of cleaner now. We don't have spines up here, we don't have spines here, or ticks. We've got our legend up here. Maybe we want to move the legend to the upper left corner, which can move it up here so that we've got it closer to the spine. And yeah, now we've got a graph. You can decide if you like this more, or if we go up, 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 let's see, or if you like this one more, so that's completely up to you. But it's nice to know that we have the option to kind of customize all of these things here. Hey everyone, it's Max and welcome back. So we've seen a lot of the customizations options that we have available for Matplotlib. We just kind of finished with the text here and everything. Now, one thing that I also wanted to show you is that there are these preset styles that you can use. So basically what I've shown you is we have a lot of customization options, and you can just, change the size of the titles and font size, blah, 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 X labels, Y labels, all of these kind of preset parameters of font size, what kind of style you want to use, if they're bold, how big they should be, oh, that is font size. Then you've got like face color, maybe even the font that you're using, all of these things. So all of these things are customizable. Now, to make it easier, there are preset customizations that you can use. So rather than having to go in, and every time you want to make like a graph or something, that you go in and you have to go into your labels and you change the font size to these specific things, you can actually load preset graphs that have certain styles attached to them, or not load preset graphs, but load preset styles that will apply to the graphs that you're using. So I'll show you first how you can see the styles that you have available. So you would go into matplotlib.pyplot, and then you would look at style, or go into style, and then just print out available like this. And so I'll just save and run this. And these are basically all the styles that are available for me to choose from. So to use one of them, I would go into plt.style.use like this, and then I would just take one of these styles and I would just copy paste it in here and make sure it's a string. And then, to show you what it does, I'm just going to run it. So, and then we can compare it in a second. So here we see we've got this preset style of this kind of grayish background with these white lines for our grid. The text sizes of our labels are a little bit bigger, as well as our title, and we don't have these axis spines that we can see here. So that's one of the styles, and of course there are other ones. So let's see, we can try this Seaborn muted just to see what's going on. And so it doesn't look all that different to me. Let's try another one, maybe something like a white grid here. Okay, yeah, so they're all kind of different. I think there's also one called presentations, if I have it installed. If not, then no, it looks like I don't have it. But there are also other styles that you can probably get somewhere, that maybe some of the graphs are made so that they're great for presentation, so that they can just kind of be copy pasted in there or something, or saved, which I'll show you in a second, actually in the next lecture, how to save. But yeah, so anyway, these are all these kind of styles that are available, and the basic idea is that all of these kind of pre-customizable things, like having a grid here, changing these text sizes and everything, maybe font color, maybe background color that we've got going on here in our graph, all of these kind of preset things that don't include the extra annotation that you add, that don't include the plots that you add, just kind of the basis, the core features of your graph. All of those can be put into preset styles. And yeah, this is pretty much how you would use them. I'm pretty sure you can get more of these. They're just located in a folder somewhere on your computer. Yeah, and then rather than having to do all of the customization yourself, you can just add them all in. And that would make it a lot easier to get consistent graphs, especially if you find a style that you like. You can always just plot graphs in the same style. Hey everyone, it's Max and welcome back. So we've gone through a bunch of customization now, and what I want to show you before we go on to creating different types of plots again is how do we save this. So rather than having to kind of run our code and then take like a screenshot of this or something, that's really not what we want to do. We want to be able to save these figures, and so I'll show you how to do that now. Now we're going to go in here after we've done everything, and we're going to go into matplotlib.pyplot, and we're going to call the method called savefig. Now it's important that we do this after we've done everything, because everything that if we put this before we've added in extra stuff, it's not going to be included. So I'll show you an example of that in a second. But first, let's just put it here. So I'm just going to call this one here a test. And basically, this would be enough to save the file. Now, what I'm doing here is I'm actually defining the file name, but this isn't even necessary. Really, this kind of just is a standalone thing, and I can just say plt.savefig, and it would be saved in as the test, and it would just be saved in wherever it is that this code is in right now, so whatever folder this is. Now, I've actually made a new folder to hold my images, so I'm going to put that in here. I'm on a Mac, so I'm going to be able to put this / here to say this is the folder that I want to go into, and then the / means I'm going to go into this folder, and then this is where I'm going to create the image. So if you see, I've loaded up this images already, and so I can right click on it here. We're in data visualization, which is also the folder that we see up here. And now if I run this code and I go back up here, then we see that if I double click to open this, so this is the figure that we've created over here, and it's just been saved into this test.png file. Now if I don't add an extension, the default is just going to be PNG. I can also add an extension here if I want. For example, if I wanted to make it a PNG file explicitly, I could write .png here. That would work just as well. So we see nothing really changes. I can also make it something else. For example, I could make it a PDF, in which case I would get a PDF file here. So yeah, we can see some of the difference here that we have for all of these things going on. But yeah, pretty much the extension that you want, you can just kind of put in here. The next thing that we can do, or actually there are many things, I'll just show you a couple. We can change the orientation. So right now we're in portrait mode, like this. And so if I just save this, this time we're going to be doing it as a PDF again. You see nothing really changes, we're in portrait mode. But I can also make this be a landscape, in which case if I save this, well, here we don't really see much. Let's see if we see anything here. No, not really either. But yeah, this wouldn't just make the orientation of the image kind of landscape-wise. So that's the one where we're just going more long like this rather than the portrait style. So in this case, it didn't really change anything. That doesn't mean that for where you have cases where this orientation would matter, you can change the orientation to be either portrait or landscape, depending on what you like. So I'm going to put this back to the default, just like this. Okay, so the next thing that I want to show you guys is that we can change something called a DPI. Now this, you can think of the resolution. It's pretty much dots per inch, and depending on what I set this DPI to be, it will change the resolution. Oh, I see why this didn't affect. Oh, well, that's not what I wanted to do. So let's go back down. Before I move on to this, let's try the landscape again, but I was saving it as a PDF, so let's try it as a PNG and see if that has any effect. Nope, so nothing visible, but that's okay. So I'll put this back to portrait. Okay, so back to the DPI, which would be the resolution. This is pretty much dots per inch, but you can think of it as the resolution. So depending on how high I put this value, so if let's say I put it at 1000, that's how high a resolution I'm going to have. But notice right now, let's just take a look at the file size. So if I make this resolution much higher, for one, actually it takes a little bit longer to run, or it looks like it's taking a lot longer to run. There we go. And we see that my file size has increased more than tenfold. So it's increased by about 20 or something like that. I think it was 40 before, and now it's almost at 800. So your file size becomes increasingly bigger, of course, if you have more resolution. So this is an option. Of course, be wary of the side effects. The more resolution, the more file size, or the more space this image is going to take up. Yeah, but basically this is kind of the basis of saving a figure. Now the only thing I'm going to do now is show you what happens if I move this thing around a little bit. So one thing that I don't want to do is I don't want to save the figure after I've shown it, because basically what happens after I do this matplotlib.pyplot.show is it's going to show it, and then nothing is really going to be, it's kind of just going to be erased. So like nothing is really going to be saved in here anymore. So if I do a plt.savefig after this, and I look at this file here, it's going to be blank. So you want to make sure that you save before you show. Similarly, if I put this in, for example, before I put in the text, and I save this, then this is how my figure looks like when I show it. But because I save it before I put in the text is actually no longer included here. Similarly, if I save this before I put in the legend, we've got the legend up here, but now the legend will also no longer be available. So that's something that you should take note of too, that you don't just want to save it wherever and think, you know, like, oh, Matplotlib, it's going to know when I'm done plotting all of this, and then it's going to save all of it in there for me. No, it's going to save when you tell it to save. So make sure that you save at the very end when everything that you have is actually in there, because that way we can ensure that we've got our text in here, we've got our label, our legend, we've basically got everything that we want to have in this figure.
Hey everyone, it's Max and welcome back. So we've done a lot of customization and everything now. So now we're going to move on and look at some of the other plots that we can do. So the first one that we're going to look at is a very commonly used one, which is a histogram. And we're just going to keep with the data we have. So what's fortunate for us is that because we're looking at football goals, the goals are kind of confined within a certain range, which makes it very nice to draw histograms with them. So we're going to stick with our data and yeah, just use that. So to create a histogram, we're going to go into the subplot that we want to create the histogram in, and we're just going to type in this keyword hist, like this. Now there are different input parameters. So the first one is going to be x, which is basically just the data that we want. So in this case, for example, we can just put in our home team goals. Now, technically, this is all you really need. So they're default values for everything else. And we can try this. So we can just run this and see what happens. And so we get this histogram, but there are weird breaks everywhere. So like we see that there's this break between 1 and 2, and also between 2 and 3, and here 4 and 5. And the reason that we have this is basically because the number of bins, so each of these is considered a bin. The number of default bins is set to 10. And in this case, it's not really relevant for us because we have a max of 6. And so we don't need 10 bins because that's kind of inconsistent with our data. So we're going to change the number of bins that we have. And to do that, we're going to access this bins keyword here. Now, there are two different ways that we can input bins. And so I'll put these in the comments. One of them is an integer, and then the other one is a sequence. Okay, so for an integer, all we say is, so for example, if we have goals from 0 to 6, then we want 7 different bins. So 0, 1, 2, 3, 4, 5, 6, that's 7 different numbers, and for each of these numbers we want 1 bin. Hence, we want 7 different bins. So if we have an integer, really what happens is we just say, hey, this is how many bins we want here. And the way that these bins work really is that you kind of have a left start and a right end. And so what's going to happen is Matplotlib is just going to create the bins for us, but it's going to, rather than take this integer, it's going to split it up into a sequence, into an array. And it's just going to give us this array of numbers that, has a starting point and has an end value. And it kind of defines the bins for us. So let me move this back up and let's just test with 7 bins first. And so what do we have? It's because I've commented it out. So I need to put it in here. So if we run this, so now we see that we've got no breaks and we've got this nice kind of histogram alignment from 0, 1, 2, 3, 4, 5, and 6. So we've got 7 bins that kind of represent each of the numbers. So that's one of the ways to do it. In this case, we're using the integer. The other thing that we can do is we can put in here a sequence. So one thing that we can do is we can put in our own sequence as an array, and we would always put in kind of the start and stop values. So for example, if we want to go, from 0 all the way up to 6 or something like that, then we're going to go 0, 1, 2, 3, 4, 5, and 6. And so what's going to happen is the first bin is going to start at 0, and it's going to go up to, but not including 1. And then the second bin is going to start at 1, including, and it's going to go up to, but not including 2. The third bin is going to start at 2, go up to, but not including 3. Then the following bin is going to start at 3, up to, not including 4, and so on, until we reach this last bin, which starts at 5. And because it's the last bin, it goes up to and including 6. So 5 and 6, in this case, will kind of be grouped together. So if we want, we can actually add in here a 7, so that we go 5 up to, but not including 6, because we actually do have 6 home team goals in here. So we do have a 6 in here, and then we can do starting at 6 and going up to, but not including 7. So if we save and run, then, well, this is the bin, or this is the histogram that we get. And so pretty much this value here represents 0, and then we've got 1, 2, 3, 4, 5, and 6, like that. And if we scroll up, we notice they look very, very similar, and they look very, very similar for a reason. Because it's basically what the integer did is just basically what we've put in here into the sequence now, is that we have this defined start and stop values. So that's how we can use these bins and put in here sequence. What we can also do is, rather than putting in an array, we can do something like use the range function and say like range 8, which will pretty much create a sequence from 0 up to, but not including 8. So from 0 up to 7, which is what we just had. So if we run that, this here is going to give us the exact same result as this one, simply because they're identical. So range 8 will pretty much give us a sequence that looks exactly like this. So I'm going to put in brackets here that we can also do something like this, just so that you guys remember. All right, so this is the bins. Now what we notice is that the bins here, they start, so like 0 pretty much corresponds, the bin corresponding to 0, it kind of lies to the right of 0. Similarly for 1, and so on and so on. So all of the bins have a certain alignment, is what it's called here. And we can change that alignment. And to change the alignment, we're going to access this align parameter. And there are basically default or 3 different values that we can choose from. One of them is going to be left aligned. So if we run this, well, I mean, you can kind of see what happens. We kind of center the bins around here. So now 0, the bin is right on top. Similarly for 1 and 2. Then we've also got the middle alignment, which is the default value. So that's what we've had above here. And we also have a right alignment, which, well, right now basically looks the same as the left. So these are the 3 that we can choose from, and depending, how you make your histograms, maybe 2 out of these 3 alignments look strange, and you just want to play around with them and make sure that you get the right one. Yeah, I mean, we can just go back to the default value. It's not that bad. I mean, this one's also nice. So we see here, for example, we're actually shifted over by 1. So here we start at 0, and here we're shifted over and we start at 1. So this right alignment is actually really strange for us, because our values start at 0, not at 1. So this whole histogram is just kind of shift over by 1. So that's also something that you should be careful of. But yeah, anyway, we'll just kind of start with the middle alignment, which we've got our number here, and then we've got the corresponding bin to the right of it. But yeah, so these are the different alignments that we can deal with, and depending on how your histogram looks, you can of course shift these around. All right, so maybe we have outliers, and we don't want to include all of these outliers. There is a parameter called range, where we can define the start and end of where we want our histogram to look at. So let's say we only want to look at goals from 1 up to 3. Basically what we put in here into this range is going to be a min and max, and they're both inclusive. So we want to start at 1, we want to go up to, but including 3. So we start at 1, go up to and including 3, which is this tuple. Here we go from 1 to 3. Now, important to note, if I save and run this, nothing's going to look different, and that's because this range parameter is ignored if I have a sequence here as my bins. So I'm going to cut this because I'm going to put it back in a second, and I'm going to put in here an integer of 4 bins. So now if I save and run this, we see things have been adjusted for us, and things look a little bit strange again. So let me try 3 there. Yeah, so 3 was what I should have chosen. But yeah, so we see that we've got now 3 bins between 1 and 3. Yeah, okay. So this is how you can move around with the range a little bit. Again, you know, we see the alignment is a little bit strange. So we start at 1, which corresponds to this bin. Then we have 2 here, which is centered at 2, even though here we've got the left edge on 2. And then we've got 3 over here. So this whole alignment thing is pretty strange. But if we look at the numbers, we've got 50 here, or about 50 here, which is what we have for 1. Got a little less than 40, which is what we have here. And then we've got about 20, which is what we have here. So the values are correct. It's just like something that you really have to be careful of is that Matplotlib sometimes does very strange things to the axes and aligning things. So that's what we have this parameter for. But I'm going to leave this out, and I'm also going to take out this range. But, you know, it's there in case you want to use it, but I'm not really going to bother with it much anymore. So we'll have our sequence in here, and we'll just go kind of back to this default representation. All right, so we can also change the color of our histogram, and that's just using this default color parameter. So for example, we can change it to red, and we've seen this color a bunch of times, so I'll just leave it like this, but of course, you know, you can put in different values, the hexadecimal or also the Rgb. So all of these can go in here. You can kind of freely choose the color here. Finally, one cool thing that you may want to do is oftentimes you may not only want to do a histogram, but you may want to do like a cumulative histogram. So that's what we can also do. Let me check the spelling on this. Cumulative. Okay, there we go. So this is a true or false value. And basically right now it's false. So we see that nothing's going to change. If I change this to true, then we don't have this histogram distribution anymore, but we've got this kind of cumulative. So 1 includes everything up to and including 1. So 1, for example, would be 0 plus 1. 2 would be 0 plus 1 plus 2. So every kind of bin takes in its own value as well as all of the values that come before it. So we can see here in a cumulative histogram, this is kind of how we build up. And each of these histograms, of course, you know, like this histogram distribution, as well as the cumulative one, they both have their perks and they have different situations where you want to use them in. And so it's really nice to just quickly be able to change this parameter. And based on this, you know, we can switch between the cumulative as well as the normal histogram, because otherwise rewriting a lot of this code or kind of messing around with the data would be really annoying. So yeah, it's nice. It's a nice little option here when you want to do or when you need to do cumulative histograms. It's a really easy parameter to change, and you don't need to change any of the data or anything like that. It's really nice. It goes really fast. Yeah, so this is pretty much the basics of histograms. There are some more things that we can do with it. So for example, the x, rather than just putting in a single value, if we want, we can also put in multiple. So I'm going to put in 2, but you can put in more. So I'm going to put in here the home team goals as well as the away team goals. And I can also change the color now. Rather than just having a single value, I can also have multiple values. So for example, let me do red and blue. And each of these colors corresponds to a single data stream or like a single data sequence. So red is going to correspond to all of the home team goals, and blue is going to correspond to all of the away team goals. So this is another thing that I can do, and I can just save and run this. And so we see that basically this histogram kind of gets split up into different bars. And Well, yeah, so we've got this histogram, but each histogram is kind of split up. And then here we've got the home team goals, and here we've got the away team goals, and then we've got that for every single point here. Yeah, so this is how you can add in, like multiple values if you want to. But yeah, all of this is kind of, there is more that we can do to histograms, but a lot of it you're not going to use. So these are really going to be the kind of core things that you're probably going to need on a more common basis when you're doing all of these histogram things. So this is the kind of great to know stuff. And if you really need anything else, it's probably available. You don't need to do a lot of reconfiguration to your code, or you don't need to do like this whole new code thing. You can just Google for it, and it will just be like another one of these parameters in this function here.
Hey everyone, it's Max, and welcome back. In this lecture, I wanted to go over some advanced concepts of histograms. So we're going to build up from our last lecture, and to do that, we're going to need to understand patches. Okay, so before we start, let's just run our old code. This is basically the result that we got from last time. We're plotting our home team goals and our away team goals here in the different colors, and then we get a histogram for each, and we've nicely combined them into one histogram. So to add something like a legend, or maybe to change the individual colors of these bars or their size or something like that, right now we don't really know how to do that, and so that's what we're going to go over now. How do we customize the histograms that we show you, or the individual items that we see here? So what we get from a histogram when we call this function here is we actually get some return values. So we get n, we get bins, and I'll go over what each of these means in a second, and we get the patches. So if we don't put any of this stuff here, basically we don't save any of the return values anywhere, but that doesn't mean they aren't there. So what we're going to do is we're going to save each of the values that has been returned into just these. These are kind of the default variable names. This is what they're called by default, but of course you can always call them something else. But by default, they're called the n, the bins, and the patches. So what the ns is the ns are the actual values in each of the histograms. So let's just take a look at these and see what we get. So let's just print out n for now. So if we print out n, we see we got two arrays here. The values are 28, 46, 49, 56, and so on. And so what these values correspond to is the actual peaks that we have here. Now each array corresponds to one of the histograms, and you can see they're ordered. So we've got the home team goals, which is in red, which is what we see first. That's going to be the first one that we get back. And now an array in essence is just a Python list. So what we're getting back a list within a list, and each element that then contains this list describes one of your values. So what we have here, this first part just describes each of the heights of our home team goals, and the second part describes each of the heights of our away team goals. So for example, if we wanted to access only the home team goals, all of their heights, we would go into n and look at the first element, so the element with index 0. We would run it, and we would basically just get this nice list here, which is, of course, we're basically just picking out the first element here. If you want to do the same thing, but not take out the second element, so the one corresponding to the away team goals, we run it, then that's exactly what we get, just like this here. So then we can, of course, go further, and if we want to access the first height, we'll go into the second element of this n list, which gives us all of the heights from our second input here, which in this case is the away team goals. And if you want to look at the height of the first bin, then we'll go in here and select element 0, which will give us 46, which is the height that we have right here. So that's what this n symbol is, but the structure that we get here is the same structure from n to bins as well as patches. So we always get a return back a list, but the size of this list depends on how many input variables we have. So if we have just one input variable, we're not going to get a nested list like here, but rather if we would just only put in the home team goals, and you can try this out, we would only get back this list. And so the structure of the bins is very similar. What the bins are is they're the
edges to each of these boxes, basically. So what the bins is going to give us, it's going to give us all of the edges to all of our histograms, again, in this shape. And now the patches, which is what this lecture is going to focus on, is it's going to give us each of these individual boxes as their own property. So yeah, let's go ahead and understand these patches a little bit more and what we can do with them and stuff. So something cool that we can do is the bars that are set here, right now we see them as like parts of a bigger histogram, but you can really imagine each bar to be its own individual element, its own individual thing, where you can change all of its properties. So it has a bunch of properties, like, of course, the obvious ones, its color, its width, and its height, but it also has like an edge color, and there's just a bunch of stuff that you can change here, since it really is just a rectangle, basically. And we're going to look at some of these things. But this is just to give you an idea of all the things that you can do. And if there's something that you want to do with one of the histograms, then of course you can always Google it or look up the documentation for it if I haven't taught you the syntax in this case, just because there are so many things that you can do with them. All right, so let's just quickly print out this patches, and it's not really going to show us much, but let's just print it out for the sake of doing it. And well, it just tells us a list of two lists of patches objects, which basically means a list like we have here of two lists, so each element is a list. Okay, not very informative, but okay. That's okay. So let's access the first patches element, or rather, let's access the home team goals, and there we're going to access the first patch. So we're going to go into patches and take out the home team goals, just like we did for n. Actually, it's probably better if I leave this here. Just like we did for n, we can look at the home team goals by looking at the first, no extra parentheses there, by looking at the first element in that list. So then we'll take out this first list here, which corresponds to the patches of our first element, which is the home team goals. And then if we want to get this first bar here, this first rectangle, then this is also just going to be the first one that we see. So again, we're going to look at element 0. And so this allows us to select basically this box here. And so something cool that we can do, for example, is we can change the face color of it by just saying set face color. And right now we've got it at red. Let's change it to orange. So we can see we can individually change the color of each of these bars if we wanted to. Now, of course, in this case, we just picked out a single element. We can also pick out the second element now. So you can see this one's turned orange, or we can take out this bar here, which is from the away team goals, by changing if we're looking at the home team or away team. And if we change that, we'll see that this one is now turned orange. So this is kind of the types of customizations that you can do. There's a bunch of other things. So for example, we can take that same bar and we can set the width. So we can change the width of just this individual rectangle here. And so let's make it really big. We'll set it to a width of 2. We can see it's basically just super huge, as you would expect. Or you can make it much smaller to a width of 0.1, which makes it much smaller. And the width is basically the same parameter that we would be defining here. It's just in this case, we can define the individual width of each of these individual patches. So now that we have this understanding of patches and what they do, and how you can use the patches that you get returned here to change the properties that you see in the front end, I would like to show you one more cool thing, basically how we can import our own patches and also how we can use them. So what we can do is we can say from matplotlib.patches, right now we're going to import a rectangle, which is basically what we have here. We've just got rectangles. All right, and we're going to use this rectangle to help us make a legend. And I'm going to uncomment this for now, and also this, so that we get our default histogram back. And then we're going to learn how to make a blue colored rectangle, and then we're going to learn how to make a red colored rectangle. So let's create actually it's probably better if we take the red one first, the red rectangle. So to create a rectangle, we're just going to use the rectangle that we've imported here from matplotlib.patches. And we're going to define some of its properties. So the first one is an XY tuple here, then we've got the height, and then we've got the width. So the XY is just going to be its XY position. In this case, we're just going to make it kind of a standard rectangle located at 0, 0 of height 1 of width 1, because it doesn't matter that much for us because we want to use it for a legend. But we'll see this in a second. Now we can also change the color of it by just putting in this color variable here, and since we want it red, we can make it red like this. So right now if we run it, nothing's going to happen because we haven't done anything with it. But what we can do is we can go into and create a legend, and we can put in here our boxes, we'll call them for now, and in here we're going to put the labels for each of these boxes. And so the labels is basically what we want each of these labels to show up. And so let's just start here with the home team goals. And our boxes are going to be the patches that we want to basically use to represent these labels. So let's run this and then let's go over it again so that we understand really what's going on. So right now what I've done is I've put the red rectangle in this list I've called boxes, make sure it's a list, and I've put the home team goals in this list I've called labels, and then I've just called a legend. So if we run this, we see now we have a red box here with home team goals. And so that's exactly what happened is what we've created here is a red rectangle. Now technically we've created a red rectangle at position 0, 0 of height 1 and width 1 that's of color red, but we didn't add it to a plot anywhere. We didn't put it anywhere. We only used it as a way of creating a label, which is, well, what we have right here. So instead of plotting this rectangle, what we've done is we've created this rectangle, we've fed it basically as input to this legend, which allows us to create this this legend indicator for our red bars here, which is the home team goals. And now we can do the same thing by creating a blue rectangle, which is only in a different color because it's going to be blue. And we'll add that in afterwards. And here we'll put in the away team goals. And now if we just update our legend, we can see that we're able to feed in these rectangles, and through that we can add this legend that we have here. And so this is a really nice way of using patches. One, of course, through getting it back from this histogram. The other way through creating your own. In this case, we used it for input to the legend so that we can create a legend for our histograms as we've seen here. Now, of course, since we have patches returned here, we could also try to use those instead. So rather than creating our own rectangle, we can go into our patches, and let's say we want to take the first element here. We're just going to go to our home team goals, then we're going to access the first element. And if we run this, we get the exact same thing. So because we have these patches returning us rectangles and stuff, we can use these elements instead rather than creating their own. And similarly, we can replace our blue rectangle with the away team goals by changing the list that we're choosing here. And so we get the same result, but rather than feeding in this blue and red rectangle, we can use the patches that have directly been returned to us from creating these histograms. Now, if we change the face color of one of them, then we can look at this specific one, this specific rectangle, since we've now changed this property, and we can add another label. Remember, we have to make sure that the boxes here and the labels here are the same length. And so this one we'll call just a special box. So we can see we've got three types. We've got the home team goals, which are in red, the away team goals, which are in blue, and we've got this special one here in orange. Hey everyone, it's Max and welcome back. So in this tutorial, we're going to take a look at bar graphs or bar plots. Now bar plots may seem a little bit similar at first to histograms, but really we would use them to show pretty different things. So we'll take an example and we're going to look at the average number of home team goals scored and the average number of away team goals scored. And so we're going to create two new variables, and we'll just create these above where we do all of our plotting just to kind of have things be nice and organized. So the first one is going to be the average number of average goals scored for the home team, which is just going to be, we'll use this inbuilt Python function called sum, which if we pass in an array or a list like we do here, it's just going to add up all of the values. So that's going to give us the total number of goals scored by the home team in the whole season. And then we're going to divide it by the length of this list. And the length of this list is just the number of games. So what we have here is the total number of goals scored in all the games divided by the number of games, which gives us the average number of goals scored in the season. And we'll do the same thing for the away team by just kind of copy pasting and changing home to away and changing this home team goals to the away team goals like this. All right, so now we've got our two variables. Let's go ahead and create a bar graph. So we're going to go into our subplot and we're going to use this argument called .bar. And so this bar method, this is pretty much what's going to allow us to create this bar plot. Now there are two variables that we're going to need to define. One of them is going to be the x coordinate. Now it's actually not called x, it's called left. So it's kind of, the reason for this is that's going to be where the left side of the bar is going to be anchored. And here we're just going to put in the coordinates that we want for our bar to start at pretty much. And then we also have the y coordinate, but it's not called the y, it's actually called the height of the bar. So how high do we want our bar to go into the y direction? And so since we're only going to be plotting two values, which is the average goal scored for the home team and the average goal scored for the away team, let's have our left coordinates be 1 and 2. So we'll have our x be 1 and 2. And the height of these bar plots are going to be the average number of goals scored for the home team and the average number of goals scored for the away team. So we'll get back into this in a second. Let's just plot it first so that we have something to look at. All right, so let's just try to move this over. So we've got, and I'll move this down a little so that we can see everything. All right, so what do we have? So, or rather, what do these arguments do? Well, here we're showing, so here we've got two bars. The first one represents the average goals scored for the home team, and so that's what the height represents here. And the second plot, or the second bar, represents the average goal scored for the away team. Now we can see that the first bar, the left edge of it here, starts at 1, which is what we have here, and the second bar, the left edge of it here, starts at 2. And so that's what these two values defined, and then these height values defined how high we go up here in this y direction. So that's what we've done right now. These bars are a little bit thick, so something cool that we can do is we can change the width of them. So the default value is 0.8, so they take up 0.8 of this kind of one scale. So we're going on a kind of 1 by 1 basis, and their width is 0.8 on this x scale. We can make it something a bit smaller, like 0.35, just so that they're not so clumped. So that's what we can see here. It goes from 1 to 135, and this one goes from 2 to 235. So they're not as clumped, so they're a little bit easier to look at. All right. Another thing that we can do is, rather than having it be left centered here at 1 and 2, we can actually change the alignment. So rather than having it be left, which right now our alignment is set to edge, so we can see nothing changes here, that just means that the left edge is going to be aligned with this coordinate here. We can change this value to be center instead. And so that means the center of our bar is going to be aligned with this coordinate here. So if I save and run this, we can see now that the center of our bar lies at the coordinate 1, and the center of this bar lies at the coordinate 2 that we've put here. Now notice the width is still 0.35. It just starts a little bit below 1 and it goes a little bit over 1. And similarly, we see the same thing for 2. So depending on how you want to organize your bar graphs, these are the kind of things that you can do. Maybe something, that would help this kind of center argument is if we want to change the ticks, and we'll do this the easy way because we don't really need to do a lot of like fine tuning. We just want to replace two values. So the ticks of 1 and 2, we're going to replace by home team and away team. So this is something that we looked at in the customization. Basically, you can see when I save and run this, it replaces the ticks, so these major ticks here, with custom values. So for example, the tick number 1, which corresponds to this one, I've now replaced with the value home team, and the tick number 2, I've now replaced here with the value away team. Yeah, so that kind of allows us to do a bit more customization and make this thing look a little bit more pretty. And of course, we can also add a title and everything that helps descriptions of our bar plots. But yeah, all of that is not really necessary in terms of, that's more of the customization, not as much as making the bar plot itself. So another thing that we can do for our bar plots is we can change our color. So right now we've got blue and blue, which may not be as nice. So maybe we want to have something be like, maybe we'll just use like red and black or something, just so that we can differentiate them a little bit. And we can save and run. And so we see I've got two values, and the first color corresponds to the first plot, which is what we see here. And then the second color is going to correspond to the second plot here. All right, so this is pretty much the basics of moving it around, and we can also change the limits a little bit. Maybe let's do that just so that we have a kind of zoomed out image of our graph. So this limits is also something that we looked at in the customization. We'll change the y limit, or actually, we'll do it the way that we learned it by going into the subplot and set the y limit to be from 0 to 2. And we'll set the x limit to be from, let's go from 0.5 to 2.5. So, x1, x2 does not exist. All right, there we go. So this gives us a little bit of a better view of this. This looks a lot prettier than this does. So we can see everything a lot better here. All right, so this is pretty much the basis of creating bar graphs. Yeah, we can see that all of this stuff is kind of able to do. So we've got our kind of left edges here, pretty much where we want to put our bots, our bars, as well as the heights that we've defined up here. This width parameter is really nice to play around with. You don't want to make it too small. For example, 0.15, because it's kind of, it doesn't look as nice. You don't want to make it too large, like 0.85, because it just looks so cluttered. But of course, it's completely up to you. You know, the arguments for having it be something like 0.5 is going to be like, if I have here, I have this be, say, 1.25 instead of 2. So these are a lot closer together. Then I want to make the width smaller. So maybe rather than just comparing the two different teams here, you know, instead of just doing home team and away team, you actually split it into home team 1 and home team loss, or, you know, all of these things, so that you've got this kind of one category here, and then you've got other subcategories that you want to plot next to each other in this kind of general region. So all of these things, you know, like depending on what you need, you can change your width and left parameters accordingly, and of course your height kind of just represents how high you want to go with the bar plot. All right, one more thing that I want to show that may not be used that often, but that's still kind of nice to know, is we can set the starting y coordinate of our bars. So we'll just, so basically the starting y coordinate here, but it's actually called the bottom. So this is really where we're going to start with the kind of the lower edge of our bar. I'll show you one use case where it could kind of be useful, but you'll probably know when you want to use this. So let's just give this a little bit of an offset and say the bottom of our home team should start at 0.2 and the bottom of our away team should start at, let's just do 0.1. And so if we save and run this, so we see our graphs are lifted up a little bit. Now it looks really silly just for doing one bar, but if we change things around a little bit, so I'm just going to comment this out and copy it so that we kind of have this as a reference. And I'm going to do a little bit of a different bar plot. Namely, I'm going to stack these two on top of each other. So the bottom one of our average home team goal scored is kind of going to be below. And then on the same location, in the same X location, I'm going to put on top of it the away team goals. And so the bottom of our away team goals should be the top of our home team goals. So it may sound a little bit strange when I'm just explaining it in words like this, but I'll plot it in a second and then we can look at it again. And let's set the y limits to be higher, to something like 4. All right, so what we've done is we've stacked them on top of each other here now. And the way that we've done it is we've set the x coordinate of them to be the same. So both the x coordinate of our home team, which is red, as well as our away team, which is black, are both at 1. The only difference is that I gave our away team goals scored, the average number, an offset, kind of a height offset, equal to the average goal scored from the home team. So I've kind of pushed this up, and our away team goals only starts at the height where our home team goals pretty much ends. And so this allows me to kind of stack things on top of each other. Now, it's not as useful to do here, but in other situations, being able to stack this is something really nice too, that also can add a lot of nice things to visuals, and maybe making the interpretation and everything a little bit nicer.
Hey everyone, it's Max, and welcome back. So in this lecture, we're going to continue on looking at bar graphs, and we're just going to look at some advanced properties with them. Basically, we're going to look at how we can do error bars. Now, one thing I wanted to let you know before we move on is that I've changed these property index here. It's used to be called left, which is what we saw in the last lecture, but now it's actually been updated with the new Matplotlib, and now instead of having it be called left, it's now called x. So I just wanted to point out that this variable input name here has changed, which is why it's changed in the code here. But it's not really going to change anything else. It's just like a small naming convention that's been changed. All right, so let's jump right into it. Let's quickly plot what we had last time, and we're just going to continue off from here. And I quickly wanted to talk to you guys about how we can add in error bars into our bar graphs, because sometimes adding in these error bars can be important. Okay, so the first thing that we're going to do is to add in error bars, we need to learn what the parameters here are. And they're actually quite simple. They're called x error and, well, y error. Y error, like this. So we'll start with the x error bars and then move on to the y. The x error bars point in these directions here, whereas the y ones point in these directions. And, well, let's just put something in for now. We can put in a single value, something like 0.2, which is going to make the x errors, well, come out in both directions, going from this position to that minus 0.2 and then also 0.2 above. We have to be careful, or we have to be aware here, because we've changed our x ticks from usual numerical values to, in this case, names. But of course, these ticks that we had before, they're still going to be relevant, and the scale that we're using here are still going to be relevant to the size of these x error bars. So if we run this, we see we get these black error bars pointing out from the top of each of our bars. So we've got the x error bars from the top of our home team goals pointing out in either direction, and then we've got the error bars from the top of our away team goals pointing out in either direction. So right now they both have the same size because we've just put in a single value. We can change that by putting in instead a list. And so if we want to give the first value, which is the average home team goal scored, a range or an error of 0.2, and the average away team goal scored an x error of 0.1, whatever that may mean in this situation. In this situation doesn't really mean much, but let's do it anyway. We can see that we can change the sizes here for each of our individual bars as they come. Now we can go even one step further, and maybe the lower and upper error bars are not the same. And let's do that first for our home team goal scored. So let's say the lower error is 0.2 and the upper error is 0.3. Then we can actually put in here in this list, rather than putting a single value like we did for our away team goals, we can put in a list containing two values, which is going to be the lower and the upper value. And now because of, well, the syntax of Matplotlib, we
We can't just leave one in here as a list value and the other one as a scalar, so we also have to change this one into a list. If we want to keep them the same in either direction, we just go 0.1 and 0.1. But also this we can change to, let's say, making the lower error a lot bigger to something like 0.4. So if we run this, we'll see here the home team goals has a lower error of like 0.2 and an upper error of 0.3. So this one, moves out much further. And here we see the opposite. We're going down by 0.4 and only up by 0.1. Okay, so this is basically the X error case. Now we can do the same thing for the Y error. So all the syntax is the same. So we can maybe just take this, copy paste it here. You can of course put in the single value. You can put in the individual lists like we've done for the X error, or you can put in these nested lists where each element is of size 2. So you've got the lower and the upper value. And then you can put in your corresponding Y errors. So let's make these ones pretty small, like 0.1 and 0.05. And this ones we can make a little bit bigger, like let's say we'll do it with 0.1 and 0.2, which will give us our Y errors. So if we run these, then we can see they pop up here. But the problem is right now we've already got our away team goals colored in black. And so the error bars and the away team goals overlap. So what we can do either is change the color of the away team goals, or we can change the color of the error bars by using this eColor variable. And again, here we can put in a single value. So we can put in something like blue, or of course any of the other color ways of defining it, RGBs, hex values. You can run, you see we change all of the colors of the error bars here to blue. Or in this case, we can put in a list and define the error bars again for each of our individual bars here. So we can say the error bars of our home team goals, which is the first element, is going to be blue, and the error bars of the away team goals, which is the second element, is going to be orange. And so if you run this, we see that we can also here individually change the colors of the error bars.
Hey everyone, it's Max and welcome back. So in this tutorial we're going to take a look at box and whisker plots, which in my mind are kind of like a combination of some of the parts of histograms as well as some of the parts of bar graphs or bar plots. But yeah, let's go ahead and create one. So we'll create it in our subplot like always. So we're going to our axis 1, and to create a box and whisker plot, we're going to use a method called boxplot. Now the first parameter that we're going to put in is going to be the parameter that we're going to define is going to be these X values, and these are going to be the values that each box and whisker diagram is going to use. So in our cases, these would actually be arrays. So the first value that's going to create this box and whisker diagram is going to be the array of all the home team goals, and then the second one is going to be the array of all of the away team goals. So array, I mean here the lists. So that's what they're called in Python. So if I save and run this is basically all I need, and it's going to create these box and whisker plots for me. So we see here the first one, this is going to represent our home team goals. We've got our median value here in red, and then we've got our first and third quartile, and then we've got some outliers up here. And actually we've got an outlier right here at 6. So we can go into our axis and we can set the Y limit to go from 0 to 7. Just so that we can see that outlier 2 a little bit better. But yeah, we see that our outliers here, they're represented by pluses. And so this represents our home team goals because that's the first X input that we have. And then the second one is going to be our away team goals. Now what we notice is that they're automatically centered at locations here now 1 and 2. And that's because the positions they're just given kind of automatically. We can define different positions if we want. So the number of positions that we need to define need to, of course, be as many as we have input variables here. So in this case, we're plotting 2 different goals, the home team goals and the away team goals. And if we want to change the position, we need to give as many positional arguments. So let's say we want to have our home team goals be at 0.5 instead of 1 for some reason. And we want to have our away team goals, the box and whisker diagram for that, be at 5 instead of 2. Then we can put these positions in here, say 0.5 and 5, and so our
box and whisker diagrams are going to be moved around accordingly. Now, I'm going to leave this commented out just because the default values that are taken on are actually quite nice. So if we don't give anything, it just kind of goes with, it starts at 1, and then it goes up by 1 for every new X value that we put in. But yeah, in case you want to change them, you of course have the option to. Now, I want to talk about these outliers a little bit here. So we see that by default we have these pluses, but these symbols is what they're called, and for short they're actually sim. We can change them, and you can think of them to be very similar as markers and scatter plots. So by default we kind of have these pluses, which is what we see here, but for example if we put in this hat symbol, then we can get triangles, or we can use our star to get stars. So whatever we want, you know, these different symbols we can put in here, and depending on that, we can get different ways of representing our outliers. So if you want to make things a bit more apparent, you can put in O, for example, which will make a big circle rather than the pluses. We'll just leave it as the pluses. But yeah, anyway, in case you want to, you know, do something with your outliers, this would be the way that you can change those symbols that represent them. All right, so the next thing I want to talk about is these whisker lengths. And we see here that for the awaiting goals, it doesn't actually look like we have any outliers. So basically everything is kind of confined within these whiskers. Now the default length of these whiskers is 1.5 times the length of our interquartile range. So the interquartile range is just the start of the first quartile to the end of the third. And so this is basically what we've got here as the interquartile range. It's this length right here, and the length of these whiskers is by default should be 1.5 times this length. But we can change these if we want. So we can change the whisker length, and we can make it shorter if we want, so we can make it half of the interquartile range, which in this case is actually extremely small. Or we can make it much larger, say 5 times the interquartile range, in which case we would actually cover all of these outliers here. So depending on, you know, how long you want your whiskers to be, this is pretty much the way that you can change all of that. If you want to make it that you cover everything, you can make your whiskers an extremely high value. So 5 seem to already do the job for us. It covers all the outliers. We can even make it something like 100 just to make sure that we cover everything. That's one way to do it. If you want your whiskers to extend from the minimum to the maximum value, you can also just put in the string range like this. And that's going to make sure that your whiskers extend all the way from the minimum value up to the top value. So you're going to have none of these outlier points. One more cool thing that you can do with these whiskers is if you put in a list or an array like this, you can put in here numbers, and these numbers would represent the percentiles. So let's say I want one of my whiskers to end at the 10th percentile, and I want the other whisker to end at the 90th percentile. And then these have to be in ascending order, like this. But if I save and run this, then my whiskers is going to be, one of the whiskers is going to correspond to the 10th percentile, and then the other one would go to the 90th percentile. So that's kind of what we've got going on here. And then we can see now we also got 2 new outliers, we can call them, at points 4 and 5 for where our awaiting goals are located. So in case you want to put them to specific percentile values, you could do that by just putting in an array here with the lower percentile as well as the upper percentile that you want your whiskers to reach out to. Now, like before, for box plots, basically we can also change the width, so we can make things bigger. I don't know, let's say something like 0.5. Let's try something like 5. Oh, my bad, that's a typo. So it's called width, not width. So 5 is extremely big. Let's try something like 0.5 again. So there we go. So now we're covering kind of a 0.5 space here, going from 0.75 to 1.25. So this here is 0.5 on the x-axis, and here we're going from 1.75 to 2.25, again covering 0.5 over the x-axis. We can make it even bigger if we want, like something like 0.8 if we want to make these much bigger, or we can make it smaller, like 0.1. I actually quite liked the default values. So I'll comment this out and just kind of let it assume the default values. All right, so these are the basic things. There's another cool thing that we can do, but that probably is not used that often, or you may not need to use that often, and it's something called a notch. Now here it's going to be true or false Boolean values, and by default it's false. So if I put in here false, nothing's going to happen. But I can change this to true, and what this does is it's going to put little notches in here around our median value. And really what this represents is something known as a confidence interval around the median value. Now, if you want this confidence interval is it's calculated by Matplotlib. So if you don't put in anything, it's going to be a pre-calculated confidence interval. But if you want to use confidence intervals and you have specific ones in mind, you can actually put those in. So the way that you would define those is by putting in, or by defining this variable called conf intervals like this. And you're going to put in an array, just like we did for x and positions. And we want to have this be the number of, we want this to be the same size as our x input values. And basically for each x, we can then define a confidence interval. So we're going to put in here two numbers, the lower and upper values that kind of correspond to our confidence interval. So let's say we want to go from 0.9 to 1.1 for our home team goals, and for our away team goals, we can go from 0.2 to, let's go like something like 1.9. And so if I put this in, then we can see that the notches change. So the notches where they end, that pretty much shows the confidence interval. You can also leave these things out. So for the ones that you don't have anything, you can also put none instead, in which case this default confidence interval calculation that's done by Matplotlib will be used. But yeah, I mean, if you want to use these notches and you have your confidence intervals, then I would suggest that you put them in. So we've got the lower and kind of upper end of whichever confidence interval really you're calculating. And then these will be represented here in the notches so that you can also see your confidence around or about the median value. Hey everyone, it's Max and welcome back. So in this tutorial, we're going to look at how to make pie charts. And to do that, we're going to create two new variables. The first one is going to be the total home goals scored, which is just going to be the sum of all of the values in here. So we're just going to add up all of the values in the home team goals scored, which is going to give us the total home team goals scored. And then we'll do the same thing for the away team goals scored. And it's just going to give us all of the total number of away team goals scored in that season. So these are the two values that we're going to use to create our pie chart. It's not going to be a very big or complicated pie chart in some sense. It's just going to take on two values, but it's just going to be the total number of home team goals scored as well as the total number of away team goals scored. All right, so let's go and get on it. So we'll go into our subplot, like always. To create a pie chart, we'll use the method pie. Now, the x parameter is the one that we're going to need to define, or the one that we give our input values to. The first one will be the total home team goal scored, and then the second one will be the total away team goal scored. And technically, this is all we really need. So we can already run this, and we see this is what we get. It's kind of hard to identify what's going on here because there aren't any labels included yet. So let's go ahead and add in some labels. And the labels is also going to be an input array. It's going to be the same size as x. So we're going to assign each of these things a label, which is just going to be a string. So let's call the first one the home team, and the second one we'll call the away team, like this, and we'll save and run it. And so we see we've got our home team, which corresponds to this blue section up here, and we've got our away team, which corresponds to the green section down here. Now, something that you may have noticed is that even though the home team goals scored and the away team goals scored, they're most definitely not values below 1, especially the total number. So what's happening here, if our x is greater than 1, so I'm just going to put this here as comments, if the sum of all the values in this x here, if they're greater than 1, each of the values in x is going to be converted to, so let's say x of index I divided by the sum of all the values in here. So really what's happening is it's being normalized. So the total goal scored is, let's say this is 500 and this one is 400, then this 500 value is going to be switched to 500 over, and then the sum of this x here is 500 plus 400, so it's going to be 500 over 900, so it's going to be 5/9. And so it's going to normalize it to a fraction, and so that our pie chart will now take up 5/9 of the total circle. Now, of course, our values aren't exactly 500 and 400, but this is what happens. It kind of does this normalization for us. Now, for the case where this sum value of x is less than or equal to 1, we're not going to have any normalization. So we'll write no normalization. So in terms of when the sum is equal to 1, that just means we're putting in all of these fractional values here. In case our sum is less than 1, so let's say we put in something like 0.3 and 0.2, it's not going to be renormalized for us, and we're just going to have, in this case, half a circle, but we can make this bigger, and we're just missing part of our circle here. So that's something important to note. In case that your values here, if they add up to less than 1, but you do want them to be normalized, then you're going to have to do that process yourself. Because otherwise it's going to be interpreted as the fractional amounts that we put in. Notice though that if these values go over 1, so we'll put in another label to make sure that we don't get any errors here. So if I left this out, it'll probably complain, yeah, so we need to make sure that these are all the same length. If I put in values that are greater than 1, then again this normalization process is going to take place for us. So like we can see, for example, if I put in 5, everything else, again, labels, everything else is going to be appropriately smaller. So if this sum is greater than 1, then we're going to get normalization. If it's less than 1, like we have here, then we're not going to get any normalization, and it's just going to interpret it as the fractional values. All right, so let's put in what we had before. But yeah, that's just kind of something important to know when making these pie charts. All right, so we've got our labels in here. There are some other things that we can do with our labels. So the first thing is pretty much define the label distance, which is just how far do we want this label to be out from the center. So this default value is something like 1.1. We can make it smaller, like 0.2, which is going to move the labels closer to the center. So this graph that we have here is actually the one that we started out with right here before we started messing with all these values. So we've got the away team and the home team, which we see here, and it's just been brought in closer, like here. So, I mean, I can also just comment this out one more time and rerun it so that we see what we had before, and then we see what happens if we add in the label distance. So we see these values move in towards the center, and if I increase this, say something like 1.5, then comparing to this fountain here, which is the default one, we're now moving out further away from the center. So depending on what you set this label distance to, you either move closer to or further away from the center values. All right, so that's how we kind of go about the labels. Now, the next thing that I want to touch on is, just like everything else, we can also define the colors of our pie chart. So right now, they're going to be, the home team is going to take on the blue, and then the away team is going to be the green. So the color is going to be like everything else in the same order. So let's have this be red and green just to try it out. And we save and run. And so also notice that the value in here in pi is called colors rather than color, which is what it's used in a lot of other things. So it's just something small to keep in mind, that here it's called colors, rather in other places it was called just color. But yeah, anyway, so all that we've really done is we've changed the value of our, or we've changed the color of our home team goals to be red rather than blue, which it was before right here. But yeah, so this is what you can do to change the colors. I actually kind of like the blue and green, so I'll set that back, but I'll leave it in here anyway. But these are the kind of default values that were given to us, but now we've defined them, and it just kind of per chance happens that these are now the same as the default values. Well, not per chance, I actually did it on purpose, but it just allows us to see how we can define these colors in here. All right, something that I wanted to show you that's kind of cool is a feature called explode, which again has to be the same length as our x input variables. But what this allows me to do is it allows us to move part of this pie chart like out a little bit, and I can choose different sections to move out. So let's just see an example of this. Let's say I want to move the away team goals and I want to just like pop it out a little bit. Now this becomes a lot more impactful when we have more than just kind of two parts of a pie diagram, but let's just look at it anyway. So the first value corresponds to the first index, of course, so that would be the home team. So since we want to move the away team, that's the second index in X, so that's the value that we're going to change. And this value is basically, we're going to move our away team part, so this part of our pie plot that corresponds to the second value here, we're going to move it along the radius outwards, and this is how much we're going to move it along the radius. Now you should know that the radius is by default length 1, and so we're going to move it kind of a distance of 0.1 along the radius. And so that we can see here that the away team, it pops out. So maybe if I just add in a third value, then we can see, to make this be black, then we can see the actual effect of this popping out. So you see this becomes a lot more noticeable when we have more pie pieces, and it allows us to show, a certain point of a pie chart. If we want to make something known, rather just than defining it by a certain color, we can actually make it stick out like we've done here, and that makes it easier to see. It makes it, it basically makes it stick out. That's literally what it does. So we can see, this is the important thing. This is what we want to look at. So that's how we can make things stick out like that. All right, so to make things even cooler, we can add a shadow. So the default is false, but we can actually set on a shadow, which will add a little shadow to our pie chart here. So these are just kind of these small aesthetic things, but if we're already doing this exploding and moving this out, even though this does have some analytical kind of visual value, it does make it easier to look at the graph and easier to read off the data that we want to read off. It also looks pretty cool, and so adding this shadow is just a small feature that we can do that, if you want to, you can add it and it just looks a little bit nicer, but this is more of like a play value technically. All right, so two more things that I want to touch at. We've already looked at, we've kind of talked about the radius when I talked about this exploding thing. So the default is set to 1, but of course we can change the radius, so we can make the circle bigger. So here we have a radius 2, and we can see it kind of proportionally, it still goes out by a value of 0.1 along the radius, but it just looks, so we can see that this distance here is the same, but it just looks smaller because we've made our circle bigger. So we've increased the radius from 1 to 2. So we've just made the circle bigger, so the gap looks smaller. We can also make these values less than 1, so 0.5, in which case the relative stick out here is going to be bigger. Of course, the gap size is still the same. So that's the radius. The other thing that we may want to change is the center value. So the default center of our pie chart is going to be at 0, 0. But we can put in here a list of just two values. That's going to be our x and our y coordinate. And based on this, we can move the pie chart around a little bit. So if we want to move it to a value like 1, 2, then here we don't actually see that much since we don't show the grid. But if we overlay different types of plots, so maybe let's add in a second pie diagram that looks identical, and let's just have this one be at -1 and -2. Then we can see, so we've got one up here, which is the one at 1, 2. We've got one down here, which is the one at -1 and -2. And then of course our label distances are now a little bit weird, so maybe we want to increase that a little bit, something like 1.5, just so that we don't see them kind of being swallowed up by our pie diagram, which is what we see going on right here. But yeah, so this is how you can change these center values, which is not that necessary if you have it, like just by itself. So if I just comment this out and do it like that, so we don't really need to change the center value at all. because it doesn't really matter. There's nothing relative to it. But if we want to add more things into the same plot, then maybe we want to position it at a certain location, in which case we do want to be able to change the center value here.
Hey everyone, it's Max and welcome back. So the next thing that we're going to look at now is going to be creating two-dimensional histograms. So we've seen a histogram before, and a histogram is pretty much this nice kind of distribution that we see, and then on the y-axis we have this frequency, and it allows us to look at distributions over one variable. So we're going to do something called, well, a 2D histogram, which in essence is very similar to histogram, but on each axis we actually look at the frequency of variables, and so what that allows us to do is it allows us to find exact frequency distributions of two pairs of variables. So yeah, let's just go ahead and do this, and then we can continue talking about it a little bit more. But let's just plot it first so that we actually have something to look at. So to plot it, we'll just go into our subplot, and to create a 2D histogram, we're going to use a method called hist2d, like this. And then we've got the basic input parameters, which are going to be x and y. So for our x-axis, let's just use the home team goals. And for the y-axis, let's go ahead and use these away team goals. Now, this actually is already sufficient for us to just create this histogram, so let's go ahead and do that. And so this is the result that you get. And now if we think back to histograms, so maybe if I go down here and just quickly, without creating extra axes or figures, just create a one-dimensional histogram of the home team goals and just show that. So it's the problem that we're seeing here is very similar to the problem that we had here, is that there were empty spaces. And basically what's happening is the exact same thing that happened before. It's just, there's a default number of preset bins, or like a default number of bins that are being chosen. And in this case, we can't really split it up, because on the x-axis, for example, for the home team goals, we're going between 0 goals to 6 goals. And if we have something like 10 bins, then we're just going to have empty spaces at some point. So that's really why we see these weird spaces going on. The other thing, so I'm going to take this back out and then rerun it. The other thing that I want to talk about is if we compare it to this histogram, it's very easy to see the frequency because we have it here on the y-axis. But here, the frequency is actually represented as a color. It's kind of like an intensity. And we'll get to that in a little bit, but just know that right now, red represents, like higher values, and blue represents low values. And then the darkest blue would just represent 0. But let's go ahead and first fix these things, these bins here. And to do that, we're going to do something very similar to what we did in one-dimensional histograms. We can define bins. Now, since we're dealing with two input variables, x and y, there are different ways that we can put in bins. So the first one is just going to be a standard integer. So for example, if we say we want 7 bins, we can just put in the number 7, and it's going to create 7 bins for us along the x-axis as well as the y-axis. So if we look at that, it works very well across the x-axis because we've got numbers ranging from 0 to 6. It does not work well along the y-axis because we've got numbers ranging from 0 to 5, and so having 7 bins here doesn't make any sense. So the next thing that we can do is we can actually split this up into a list or into an array, and the first value, and I'll put this in brackets behind here maybe, or let's see, I'll put this in here as a comment. The first value is going to represent the x bins, and the second value is going to be the y bins. So just so you know that what we're defining here. So for the x bins, we want 7 because we've got values ranging from 0 to 6. For the y bins, however, since we're going from 0 to 5, that's going to be 6 bins in total. So we want our bins to be 7 and 6. And so we see that we fixed this little space here. Now we've got 7 bins down along this x-axis. So all of our rows are made up of 7 bins. And then here, columns pretty much, so the columns, we've got 7 different ones along the x-axis, and our rows, we've got 6 different ones up here. So we've got 6 bins along this y here, and we've got 7 bins along this x. Now, of course, what we did before, we could either put in these integer values, or we can actually put in arrays or lists or sequences that give the definite, like start and stop positions of each bin. So for example, we can use these range functions. And so if we want 7 bins and we want each bin to go from like 0, 1, 1, 2, 2, 3, etc., then basically what we want each bin to start at an integer and then end at the next integer. So we can use this range function very nicely for that. And we want to make bins that range from 0 up to 6. So we can put in here, we can put in here a range of 8. And so our 6 is going to be kind of its independent bucket. And then we also want to put in here a range of 7 so that the 5 one is going to be its own independent bucket. Because remember, the last bin, basically, so if we've got bins like 0, 1, 2, and 3, it's always going to be from 0 up to but not including 1, from 1 up to but not including 2, but on the last bin, it's going to be from 2 up to and including 3. And so to not get that, we're going to actually make this go up one more. So like this, for example, that we would have from 2 up to but not including 3, and then we've got from 3 up to but not including 4, so that we can count all of these 3 values that occur too. So that's basically why we're adding an extra value in here into the range. So if we run this, then these are the bins that we get. So in this case, we still have 6 up here, and we should still have 7 down here. Yeah, as we can see. All right, cool, great. So these are the bins. Of course, you can see there are different ways to put it in. Just like one more quick note, so we don't have to put this in as an array. Technically here, we can also just put in a single list or a single array like that, which would then, very similar to just putting in a single integer, give us the same number of bins across the x and the y. But that's not really what we want. In this case, it's actually not that bad because our bins are defined, and so everything up here doesn't exist because the away team never scored 6 goals. Sorry about that. So we're not going to get this random space in between, but we would just still have like an empty row up here. So it's not as bad as putting in the integer values, but of course we can do better by putting in these exact array values like this. All right, so this is basically how you can go about creating these 2D histograms, and you can see that they're very similar to the one-dimensional histograms. So one more thing that I want to quickly touch on that we are going to get back to is interpreting these color values. So right now, really what we need to do is we're actually not going to do it into our subplot. We're going to just do it into the general matplotlib.pyplot function or class using this hist2d method. And then we can very easily do a plt.color bar. And don't worry about this too much. This is really, I just kind of want to show you what this will do. And so if we do this, then we see we get this nice color scale on the right here, and it shows us what values these colors represent. So we see like this very dark blue represents 0, and this very dark red represents 18. So here, for example, the score of 2 goals for the home team and 1 goal for the away team happened apparently 18 times. So those are some of the things that we can read off here. Now, of course, this isn't the perfect solution, because if we have more axes, then basically we would always have to do is we would have to set the current axes so that we can use this PLT rather than going into the axes like this. The reason I don't want to show you yet how to do it into the axes, but we will learn, is because it involves images, and that's the next thing that we're going to look at. So once we've covered showing images, we can then go back to implementing this color bar with the axes. So that where everything is complete and we're not just skipping around all over the place.
Hey everyone, it's Max and welcome back. So the thing that I want to look at now is how we can load images and how we can show images. And so images are kind of nice because maybe sometimes you want to have, or you have data and you want to display it onto a background image, and so being able to get that image in is important. Or maybe you just want to have an image that is part of your whole data visualization concept, whatever it may be. If at some point you need images, we probably need to know how we can get that into our Python code and how we can go about visualizing all of those things. So that's what we're going to look at now, how we can load images and how we can show images. So we're going to need to import one more module. We're going to import matplotlib .image, and this is going to allow us to pretty much deal with all of these images. And we're going to import it as matplotlib.image, and we'll import this as matplotlib, so mp or mpimg. So this is just going to be short, matplotlib image. But really, I mean, you can call it whatever you want. I just don't want to have to write out matplotlib.image every time. All right, so the first thing that we'll do is we'll learn about how we can load images. And we'll just go through everything first, and we'll go about displaying the image. And then we'll talk through and actually understand what's really going on. So to load an image, I'm going to go into matplotlib.image, and I'm going to call the method called imread. Now this works very similar to just opening files in Python. So in Python we would just write open, and then we've got like a file name here, and maybe we want to have the mode. So in this case, you know, the mode would be like reading or writing or appending or whatever else there is. So we don't really use the mode, but this file name is similar. So with the open, we're saying this is the file that we want to open, and with the imread in the matplotlib.image, it's very similar. We just put in here the file name of the image that we want to open. So in this case, I've included a sample image that I just call target.png, and all I need to do to load this image is just, you know, this is pretty much how I'm loading the image using this imread function. And basically what you can think about it is that it's this open method, or this open function that Python has, but for images. Now, for everything with files and stuff, so if I open a file, I still have to save it into a variable. So in this case, I would save the file maybe in the variable named f or whatever. And so we'll do something very similar. We're going to load our image, but to be able to use it later, we're going to save it in this variable that we're just going to call img, so short for image. And so really what we've done is we've just kind of loaded this image, and now we have this image accessible to us in this img variable. So that's the one part of it. This would be the loading the images. Now, before we quickly move on, one thing that I want to touch on is here I've actually, I've specified that it's a PNG file. You can, there's actually the option here too to specify a format. So you can specify this variable. And the formats can be like PNG, PDF, you know, all of these image formats. If you don't specify a format, then it's going to try to guess it, or it's going to try to figure it out rather. And if it can't figure it out, it will use PNG and try to open the image format then. So if for some reason you have like a different image format and it's not a PNG, and something's not happening, maybe try specifying this format parameter and putting in the image format that the image is in. All right, yeah, so maybe I'll put that right here, that we can also specify the format if we want. So just so that we can see that as a comment here. All right, so now we've loaded our image in, now we have to display it. So we're gonna go into our subplot, and we're gonna use the method imshow. And so this is just kind of part of everything that we've been doing before. So we've created the figure, we've created our subplots, and now there's a method that we can call on the subplot just called imshow. And this is gonna allow us to show the image into this subplot. And basically all we have to do now is just specify the image that we want to show. And right now we've loaded this image, or we've loaded this image file into this img variable. And so the image that we want to show in our subplot is this img. So if we run this, we see here, this is the target image. It's an image of a target, and I've loaded it into this img variable. And now using this imshow, I am displaying this image in our subplot here, this axis 1. All right, so this is basically how the images go. Now, I want to give you a little bit of background, just so that you understand what's really going on here. So the format that this imshow takes is basically it takes in something like a matrix. So the format that it's going to take in is something like an m times n format. So you've got rows and columns, but basically, you know, you have a big matrix, and those are going to specify your points at each place. So this is one of the formats that you can do, and if you use this format, then basically you're not assigning color values. So the intensity will be determined based on the value inside of these matrix. So for example, if we have a very short matrix, let's say we have a 2 by 2, so m and n are both 2, then the matrix, I'm just going to write it out, could look something like this, 1, 2, and something like 3 and 4. So this is how it would look in array form. If we write it out, then it could look something like 1 and 2, and 3 and 4. So depending on how you organize these, so it could also be that these ones would specify the row, yeah, and then so we've got the column here. So something like this. So basically this is kind of to unabstract this. This is kind of how you can think about it, that we have this matrix, and if we put in more values, then we're going to go more in this direction, and we're going to go more in this direction for everything. And if we put in more values here, then we're going to go more in the down direction, but we're going to go more in the down direction everywhere. So that is just kind of all consistent, like we're building out a big matrix. All right, anyway, so that's kind of what's going on here. We can also make this three-dimensional, so we can have this be an m by n times 3, in which case we also specify Rgb values. So this 3 would add this extra third dimension, which would then specify Rgb values for each point. And so rather than just having intensity values like we would from these values here, we would actually have Rgb. So each of these intensity values would be replaced by an Rgb. So this would then go to something like this. So in here, I'm just going to write Rgb, and like this. So, and then Rgb is going to be some color array. So we've got the R, G, and the B values in here. So we're going to have a three-dimensional matrix pretty much. And each point has associated with it these certain color values. And so if we're using colors, this is how we would specify the matrix, basically, that we have each point, and each point associated with it has a color value. And so that's basically how all of this can be built up. This can actually also be m by n times 4, in which case Rgb would be an Rgb alpha value. So we would have an extra alpha parameter, so like transparency or opaqueness in here. So it can also be that we have this be of size 4 rather than 3, in which case we would add this alpha value. I'm just going to put this in brackets, saying that it's not mandatory, but it is an option that can be added in. So let me just finish writing all of this out here. So this is the theory, basically, or not the theory, but this is the back end of how all of this imaging reading the images, how that works, as well as displaying the images. And so that's what this imread method does for you. It pretty much breaks down this image, transforms it into this big matrix that contains all of these color values at each point, and then this imshow, it retransforms this big matrix and their associated color values at each point into an image that we can see here. And so the way of doing it is very short. We've basically got one line of code to read the image, the next line of code to show the image, but just so that you kind of understand what's going on in the background, this is what's going on. So each point has an associated Rgb value with it. In this imshow, there are other parameters that we can define. There are actually many other things that we can define. We're going to look at one of these in more detail, which is known as a color map, but we'll do that in the next tutorial, because in that tutorial we're going to go more into color maps and all of that stuff. So yeah, this is basically the basis of just loading an image and directly showing it into a graphic. And so it's really this easy to just take images from your drive and just include them into your data visualizations.
Hey everyone, it's Max and welcome back. So in this tutorial, we're going to look at something called color maps. And we're going to continue on using our example that we used for the 2D histogram. So if we just run this one more time, this is pretty much the result that we got from it. And we see that we have colors here, and we've got this color bar here that pretty much tells us, what color corresponds to what value. And these colors, or the colors that are used to represent this, we can actually change. So basically what's happening here is there's a color map assigned, and we can kind of see this idea of a color map better here. So the color map ranges from dark blue to dark red, and basically just a certain color assigns a certain value. So that's what we're seeing here. Now the color map that we're using it just goes from blue to red, and it's called jet. But yeah, I'll talk about color maps. I'll show you some examples, and hopefully then you'll get an idea of what color maps are, as well as how we can change them. So like in our 2D hist method, there's actually another property called CMap, which lets us define the color map. Now, right now, the basic color map, like I said, is called jet. But how do we get these color maps? Well, to get them, we would go into matplotlib.pyplot, so into PLT. Then we would look at a subclass, CM, so for color maps. And now we can just put in the name of the color map that we want. And the name here, we're not going to put in the form of a string because it's going to be an attribute of this CM class here. So what we're actually going to use is, for example, if we use jet, which is the one that we have here, we wouldn't really get anything to change, but our code won't crash, and this is just kind of to show as an example. So this color map that we're using is called jet. So that's what we can see here. We go from this deep blue to this deep red, and these colors then correspond to certain numbers. All right, so this is just one example of a color map. There are, of course, many more, so I'll show you another one. One of them is called hot, which goes here from like an almost black to a very bright yellow, almost white, or basically white. So we see that the colors that we had here were from blue to red, and now we've changed the color map, and so the intensity values and everything and the numbers or the colors that are assigned to numbers also change because we're using kind of a different color basis for numbers. So hot's another one. Then there's ocean, for example, which goes from green to white again. So like basically you can see that, like these color maps, there are very many of them. I would say there are probably at least 100 or something, but I haven't counted them. So there are very, very many color maps, and depending on what you want, of course you can choose different ones. Now, our color map here, so the transitions don't look super smooth, and that's just because, we've got very rigid numbers from 0 up to 18, it seems. And so like we don't have very much room for smooth transitions. But actually, if you look at this color map here, you see there's it almost looks like, this color spectrum is continuous. And so if we had a lot more values, we can actually, like squeeze these numbers down, and rather than having 18 here, maybe we have 200 or something like that, in which case the transitions would also become a lot smoother. So the transitions can look like we see here in the color map. Yeah, so this is kind of the idea of color maps, and of course there are very many to choose from, but it lets you customize a lot more with colors and how you want to represent things. So if you ever want to reverse a color map though, so for example, we want to use green as our maximum and white as our minimum, the way that we would do that is we would put an _r after the name, like this. And this, then we can see here, we've got green as the maximum now and white as the minimum. I'll show it for the other two also. So for hot, if we scroll up, before we had white as the maximum and black as the minimum. Now if we use this _r, we've got black as the maximum, white as the minimum. And similarly for jet, where we had red as the maximum, blue as the minimum, we now have the opposite going on here. So this is how you can get the reverse color map. Just, kind of to let you know, because you're not going to find like another name for this color map. This color map is still jet, but it's jet in reverse order, and that's why we have this _r. So I'm just going to take this, move this here, and then I'll leave that as a comment here just in case. So this is kind of your reference, that _r. This gives you the reverse color map. All right, so this is one application of color maps. In this case, it was on two-dimensional histograms. There's one other thing that I wanted to show you, and this is going to be a little bit more involved, but I'll walk through all of it. And basically, what we're going to do is we're going to create a normal histogram, and all we're going to do is we're just going to plot a histogram of our home team goals, and let's just use, or we'll define 7 bins so that we don't have any empty spaces. So we've seen this before when we were doing our histograms. Actually, it's put in here, range 8. That probably looks a little bit better. Yeah, there we go. So when we were doing histograms, we've seen this before when we got into this method about drawing histograms. But yeah, so now I wanted to show you though how we can actually use these color maps and apply them to change the individual colors of the bins here, for example. So this is just an example applied to the bins of a histogram. Of course, like you can pretty much use this on anything else. You can use this to have color map transitions for scatter plots or all these sorts of things. But I wanted to show you the example on histograms. Okay, so the first thing that we're going to do is we're going to get the color map, and we'll just save it in this variable cmap. And to do that, we're going to go into matplotlib.pyplot, and I'm just going to walk through this first, and then we'll review it afterwards again to kind of make sure what's going on. But it's easier to explain if we actually have some visuals and complete code rather than trying to explain it abstractly. So we're going to matplotlib.pyplot like before. We're going to go into this color map module, or this color map class, and now we're going to use a method called getCmap. And basically the input parameters that I need here is the name of the color map that I want to put in, and then I can also provide like a number, and which I will talk about in a second. So the name, let's just use the jet color map. So that's basically this one here. So this is the jet in reverse, but this is the one that we're going to use. Notice here I put it in as a string because we have to now provide it as input to this method here. And the n is how many colors or how many blocks basically I kind of want to split it into. So like what number do I want to assign the maximum? And we'll get back to this in a second. But right now I'm just going to put 7 as the maximum. All right. And now I need to get the colors out of here. So I'm going to save the colors in a variable called colors, and I'm going to go into my color map that I just created, and in here I can actually put an input of arrays, and that's going to give me back the corresponding colors. So for example, in here I can put this range 8, which is going to give me numbers from 0 to 8, and actually I'm going to change this number from 7 to 8. Basically what I'm doing here is I'm putting in a list of like 8 values, or a sequence, in this case of 8 values, so that I'm putting in the numbers like 0, 1, 2, blah, 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 and so on. And for each of the numbers that I put in here, I'm going to get back the corresponding color from the color map. So that's the idea. Let's just use this first. And then let's talk about this again, and let's change some of these numbers, and then when we play around with it, I'm sure you'll probably better understand what I'm talking about here. But yeah, so just for annotations, here, the corresponding colors is what we get out of these numbers. Okay, so there's still a little bit more that we need to do. One quick thing that I want to introduce, and we will talk about this again later, but basically, when we talk about, or when we call these histogram methods and stuff, we just usually use them like this to apply them to our subplot. But actually, just like methods, well, just like normal methods, just like normal functions, they also return values. And so we're going to catch the values that they return, which is, in this case, we'll just call them n, the bins, and the patches. And so what this histogram method returns is n, which is just basically the value of each histogram bin. Then we've got bins, which is the edges of all of the bins. And we've got these patches, which are pretty much these objects here. And now these objects here, these patches, you can kind of think of very similarly to when we did ticks. We were able to access each of these tick objects themselves individually. And so we're going to do something very similar, And I'll keep comparing this to ticks so that you kind of have like a reference point of what to compare this to. We're going to use a little for loop. So we're going to say for color and patch and then we're just going to use this little zip function that Python provides to zip up colors and patches. And really all this does is it allows me to use this kind of for loop so that I'm going through the colors array here, or the colors list, I'm going through the patches list, and each time I'm taking on one of the values. So if you don't know this is pretty much like doing, or it's an easier way for me to do this. So like for I in range ling of the colors. So I want to go through all of the colors and then doing something like this, color equals colors I and patches, or patch equals patches I. So rather than having to go through numbers and then assign each value based on, the index, rather than having to do all of that, I can just zip these two together and I'll take on, I'll go through both lists one by one and each value will be stored in the corresponding variable. So first I'll take on the first color, which goes into this color variable, and then I'll take on the first patch simultaneously, which is, well, the first element here in this patches list. And so I can use both of these at the same time. And they're always at the same corresponding index. All right, so now if we think about these being ticks again, so what we were able to do when we went through ticks is we were able to go into our tick and we were able to like set certain properties. And so we're going to do something very similar with the patch. So the patch, just like the tick, has methods associated with it, and we can set certain properties. In this case, we want to set the face color of the patch, like this. And so all we need to put in here now is just the color that we want to set the face color of this patch to. And so before I run this code, basically just going through this loop again, is we've created, just think of this colors right now as an array of colors. I mean, we got it from the CMap here, and I'll get back to this in a second, but really just think of it right now as something like this, red, green, and so on. Or it could also just be like RGB values, like 0.5 and 1, or we can also have like an alpha value in here of like 1, like it can be RGB or RGB alpha or something, it doesn't matter. Just think of this as a list of colors. And these patches, each of these patches just, it represents each of these histogram bins here, so the objects themselves. All right, so I'm going to run this. And what we can see now is that I've changed the color of each of the bins, and they actually follow the color map that we have up here. So that's the result of this. And the way that I was able to set every single one of these patch colors is through looping through every single one of these patches and setting the face color. So again, you can think of this as being very similar to how we dealt with ticks. And the way that we got it is just that these, well, histogram, but really everything else too, like lines and scatter plots and everything, they all return values from them. And they also all return values that are associated to the method. So for example, like just doing the simple plot will return to us the line that we get. So like all of these methods return the objects inside of them to us so that we can actually manipulate them. And we're going to do that here using these patches. All right, so let's get back to these color map things. And let's see, first of all, what happens when we change this number here. So what I've done now is I've set 8 as the maximum. So basically the number 8 corresponds to the highest color. If I set this lower, let's say color 7, then we see here, this is actually the highest color that we can get. If I change this even lower, so right now I'm putting in numbers from 0 up to, well, let's write this out, from 0 up to 7. And if I have the highest color be at number 6, then 6 and 7 will be the same color because there is no higher color than corresponding to number 6. So basically we see that these two take on the same color. If I do it as 3, then 3 is going to be the cap out for a color. And so that's what we see here. And the color map also gets a lot shorter. So now the colors, they really only go from like 0 up to 3. So that's our big color map here. We can think of it has been compressed down from 0 going to 3. And it has to fit all of this color spectrum into that small range of values. So that's basically what we're doing here is we're setting this peak, this cap. And so if we set this much higher, so let's say, actually let's do it about twice as long as our list is. If we do it at 15, then we're only going to capture half of the color spectrum. If I set it to something like 100, we're really only going to use the bottom 8 numbers in this case of the color spectrum, which is barely getting out of the deep blue end. So based on this kind of allows you to set, it pretty much allows you to set the range that the color map is going to cover. And so depending on how many numbers you need, so for example, if we wanted to do this in a scatter plot, these home team goals, they have about 150 values or something like that in them, 140. And so maybe for that, if we wanted to do a scatter plot, we would split this into 140 different colors so that each point basically can take on its own individual color. So that's kind of the idea of that. And I mean, for the scatter plot, it'd be easier because we can define a color for every single point. Whereas here, if we put in a color, we actually can't put in a list of colors like this, because what this is going to correspond to is each of the elements in this list corresponds to basically like one whole data thing. So it's not, if we put in a list, it's not going to just be like, okay, that's what you want the individual blocks to be colored. No, it doesn't let us do that. It just, you can put in one color and that's going to be the color of your whole histogram. And something to note too, if I do put in a color now, nothing's going to happen. And that's because we're overwriting the colors here. All right, so that's this thing. And then basically the other thing now, hopefully you understand this a bit better, is once we've set this value of what we want to, like set the maximum value of our color map to, now that we have this predefined range of, in this case, 0 being this dark blue and 140 being this dark red that we see here, then we can put in an array of numbers and we get back the corresponding color values. So for example, if I print out the colors, then what we see is just these Rgb alpha values that we're using. And we see here that we've got 0 in the R, 0 in the G, so we're basically full on blue here, which is also exactly what we see. Hey everyone, it's Max and welcome back. So earlier when we covered two-dimensional histograms and color bars, I told you that I was going to show you how we can create these color bars and add them without having to use this PLT general thing, but rather going directly into the axes. And we needed to cover several things, which we've covered now, so that we can do that, so that we actually understand what's going on. So now that we've covered everything, let's go ahead and get back to it. So the first thing that we're going to need to do is we're going to change this now from PLT to axis 1. But what we're also going to do is we actually want to save the values that come out of here. So the first thing we need is, well, actually, I'll just name the variables as they come out. So they're the counts, the edges, the y edges, and the image. And basically, what's going on here is the counts, these are the values here. So like the height of each of these are like, so for example, here the count would be like 18, and here we've got something like 16 and 14. So we've got this matrix that has the counts of these values. So it basically has the height that corresponds to each of these boxes here for our histogram. So that's what we have in here in the counts. In the x edges, it's very similar to what we did in histograms. So when we did this for histograms, saving out the values, then basically what we had here were the bins, which were the edges of the bins. In this case, since we have a two-dimensional histogram, what the x edges are is that they're the x edges of the bins, as the name kind of suggests now. And so now y edges, you can kind of guess probably that these are the y edges of each of the bins. And then we've got this image thing coming out here, but that we really don't need to worry about. Really, we just care about the counts here, which is kind of the height or the intensity value of each of these, and then the location of the bins. All right, so we've got these out. What are we going to do now? Well, what we're going to do is we're actually going to show this now in an image. So we're going to go into Axes, and we're going to do this, or we're going to use the imShow method. And here, basically, we can put in the counts, which is the height value of each of these. Now remember, when we talked about images, when we put in these, when we just put in like a matrix with values, it's gonna, so if I take this off and if I just run this, remember this is basically how we did images. So like we can put in here these RGB values and everything, and images basically show like big m by n, in this case by 3 or by 4, taking these matrices, and each point kind of has a color value associated with it, and that's how images are shown. So yeah, that's basically what's going on here. What's cool is in images, so we can define a new color map if we want. I'll just leave this in here as the old color map, so just still using jet like we did before, and the jet color map, that's also the one that's still caught in here. But in case we want to, we can use a different color map, and so like the colors that we have in here will then be, you know, mapped to whatever it is we want. So for images, we didn't cover this when we looked at images because it wasn't necessary then, and we also didn't know about color maps. But now that we do know about color maps, you can also know that we can put in the color map here. Of course, it may as well just be easier to define the color map here. .cm.jet, for example, which is the default one, because that's where we're going to get these counts and everything from, and then the color map will already be captured inside of these counts with the RGB or RGB alpha values. All right, so that's the one thing. The other thing that we're going to need to do is we're going to need to set something called an extent. So we'll talk about this now, basically. So what we can see is if we compare what we have here to our histogram here, it's not quite accurate. So for example, our highest peak is here at 2 to 1, and that peak is actually kind of located here at 1, 1. And of course, I mean, something that you can see immediately is here we've got very kind of rough colors that have no transition. And basically this imShow, it makes it more like a heat map. So the color transitions have become a lot smoother. In essence, they're transitions rather than just blocks of color. All right, so we need to talk about this extent a little bit. And what the extent is, it's basically we have to define where we want the bottom left and kind of the top right coordinates of, or what are the bottom left and the top right coordinates of what we're putting in here. And then the image will get stretched accordingly so that it actually, you know, the values down here actually correspond to the right values. And so what we need to put in here in the extent is just basically a list, and then here we've got the left, the right, the bottom, and the top. So that's what we need to put in here. And the way that we're going to do that is, rather than setting them by hand, which we can do, is we're going to use our x edges, and the left value is going to be the leftmost edge. The right value is going to be the rightmost edge, which is the last value for x edge. The bottom value, now technically you would think the bottom value is the bottom, so the first value in the y edges, and the top value will be the last value in the y edges. And if we print out these y edges, then that's what it would seem to. So let's not define the extent here yet. So if we print out the y edges, we see they go from 0 to 6. So we would want the top value to be 6 and the bottom value to be 0. However, there is a problem with that, and that problem is actually due to how imShow works, and we'll talk about that in a second. But let's first implement it and see what the actual problem is. So if I implement this, we see that all of a sudden it gets flipped. And so why is that happening? So let's take a little quick detour back to images And I'm just going to go down here, and I'm going to quickly load the target image that we used earlier in our example of when we covered images, and I'm going to do a imshow for this target image. So if I show the target image, I want you to take a note of the y-axis. And so what's happening is that the y-axis actually starts up here at 0 and goes down with increasing value, rather than starting down here at 0 and goes up, which is what happens for basically everything else. And so the effect of this is that we actually need to flip the y-edges. So in this case, the bottom will kind of be the top, and the top will be the bottom. And that's just because our y-axis here has been is flipped, and that's just kind of the nature of this imshow. So yeah, that's just something to keep in mind, and that's why we need to flip the y-edges here. So the bottom is actually the top, and the top is the bottom. Again, because our 0 is now in the top left corner rather than being in the bottom left corner, which pretty much reverses our y-axis. And so we need to reverse the values that we put in here too, since we're now referencing from the top. All right, and so when we've done that, if I just take this out again so that we can look at the histogram before and then put this back in. So now things look a lot better. We've got our peak here at 2.1. It's a little bit harder to read actually, so this distribution is much nicer to read, but we can see the same effect here. Now the last thing we need to do is we just need to add in the color bar. Yeah, and to do that, we're actually going to add the color bar to the figure. So the color bar is going to be a property of the figure, not of the axis itself. So we'll go into the figure 2, which is where we put in this axis. And here we're going to call the color bar. Basically, oh, sorry, so I forgot one thing. We need to save this image that we're showing as the image in here, because this is the image that we want to set the color bar on. So the values that we see here in the color bar, that's what we want the values in our color bar to be represented. So if we're showing several images that have very different scales, so here we're using like 0 to 20, if we have another image that uses scales of 0 to 1,000, we want to make sure that if we show a color bar for this one here, that the color bar actually represents the values from 0 to 20, not to 0s to 1,000. And so now to apply to the axis, we define the axis that we want to apply it to in here. So we set the color bar in the figure, and we define the axes inside here. And this is the image that we want to apply the color bar to, in case we have, two axes that, in this case again, from 0 to 20 and 0 to 1,000, we want to make sure that our color bar actually takes on the right values as it does here. All right, yeah, so this is how we can add in color bars now using axes and stuff. And what's nice is it actually took in a lot of the stuff that we learned earlier. So we looked at the color maps that we can apply here. We also, again, had to go back to images. And here it was very important for us to understand how the imshow method actually works, and that we're putting in these matrices here, each of which has their own color value, as well as looking back at the images at the imshow method and seeing how the y-axis is actually flipped, which is the reason for why we need to flip these top and bottom values here. Otherwise things, like you would probably figure it out, but it'd be confusing, like why do I need to flip this? And it's just generally good to know that when you load images that the y actually starts here in the top left at 0 rather than here in the bottom left, which is pretty much the case for everything else. Hey everyone, and welcome back. It's Max, and in this tutorial we're going to look at how we can do 3D plotting. So the two plots that we're going to look at in this tutorial are going to be line and scatter plots, and we're going to do them in one because we've seen them before in the two-dimensional case, and really in the three-dimensional case they aren't that much different. It's basically just adding one variable. So we can just look at them both now rather than having to cover them in two different tutorials, because I think this would be a little bit more efficient. But anyway, let's get started. So the first thing that we're going to need to do is we're going to need to import the ability to do 3D plots. And to do that, we're going to go and say from MPL toolkits.mplot3d. So this is basically like extra libraries that kind of add on to Matplotlib, and they're like these extra, well, they're the Matplotlib toolkits, and they're like extra cool features that kind of go above the normal capabilities that Matplotlib had first. And so like one of these things, for example, what we're looking at now is going to be this axis 3D, so 3D plotting. So from MPL toolkits .mplot3d, we're going to import axis 3D, and this is just going to allow us, or it's going to give our axis 3D functionality. Yeah, so basically the subplots that we're going to create, we now have the option to define an extra parameter that's going to allow us to do 3D plotting. And the way that we can do that is we keep all of this, so we keep the creation of the figure, keep the creation of the subplot to the figure, and we're going to add an extra parameter, and we're going to say projection is equal to 3D. And basically that's it. So what we've done is we've now, by importing this extra library and by defining this projection parameter to be three-dimensional or 3D, we now have the ability to do 3D plotting. So how are we going to do that? Well, let's just start off with a normal line graph. So we're going to our, or a normal line plot. We'll go into our subplot that we just created that has this 3D projection on. And just like we do for the two-dimensional case, we're going to call this plot method. And we're going to put in our x parameter. So x, we'll just say x. And actually here they're called x's. And then we've got y's and z's. So you don't have to put these in. You can just kind of leave them out. But, well, let's just leave them in for now. And then we can take them out in a second. So our x is going to be this x parameter that we've always defined here. Let's have our y be the home team goals. And let's just have our z parameter be the away team goals. So really what we're doing here is, well, instead of doing like a two-dimensional plot, like a flat plot, we're now going to be in three-dimensional space. And each point has an x, a y, and a z coordinate. So we've still got like about 140 data points or something, but now some of them are going to be kind of moved up or down out of the two-dimensional plane that we looked at before. So yeah, anyway, let's just take a look at that. If we run this, so this is what we get. So the line plot's pretty messy just because it connects subsequent points. But basically what we see is we have our x's over here. This is our x-axis. We know that because it goes from 0 to about 1. Well, it goes to 160, but it looks like it stops here at like 145 or something like that. So that's just kind of the game count. Our y's are our home team goals, which we know to be this axis because we know our home team goals, one of them has an occurrence of 6. And our z's are the away team goal, which is going to be this axis right here. Now, this isn't the best example to use a line plot on. Nevertheless, it kind of shows what we can do with it. And of course, you know, like all of the parameters that we could do in the two-dimensional case, we can also do in the three-dimensional case. So like color, line width, all of those things. And you'll notice that the method I used here is the exact same method I used in the two-dimensional case. So like two-dimensional and three-dimensional case, even the methods that I'm calling here are basically identical. It's just by adding this projection 3D, which I'm allowed to do because I've imported 3D capabilities to my axis, I'm allowed to add in the z parameter here, which makes everything 3D. So now let's just quickly label each of the axes. So to show you how we would go about that. So we know how to set the x label, and here we can just call this game number. We've also seen how we can set the y label, and we'll call this the home team goals. And you can basically already guess how we can set the z label. It's the exact same format, just we'll have a z here, away team goals. And if we save and run this, now you can also better see, you know, which axis really is, or where is which axis, in case these numbers aren't so clear to identify. So now we see our x-axis is over here, it's the game number. We've got our y-axis to be right here with our home team goals, and our z-axis, which has the label away team goals, is this one here. All right. Yeah, let's just go ahead and continue on with scatter plots. So we're going to put this into the same figure. We'll have the axis 1 be the 2, 1, 1, and then we'll create a second axis, which is going to be our 2, 1, 2. So it's going to be our second row basically. And we're going to go into our axis 2 in this case. So here is 3D line plots. On our axis 2, we're going to do a scatter plot now. And again, here the keyword is just like we had in the two-dimensional case. We've got the x's, the y's, and the z's. There we go. So we'll just use the exact same values as we did above. So our x's are just going to be the x. Let's have our y's just be the home team goals, and our z's are going to be the away team goals. All right, and basically we can already plot this. And here we've got our three-dimensional scatter plot. Here we've got our three-dimensional line plot. I've put them into the same axis so that we can kind of compare them if you like. The same setting, of course, applies to the scatter plots as well. Also, if you wanted to set the title, because we're doing this on the axis, or let's just call this 3D line plots. Since we're doing this on the axis, this extra 3D functionality won't really change any of this stuff because this is all part of the axis, and this just has this extra 3D capability now, but it doesn't change any of the stuff that we could do in 2 dimensions. It doesn't take anything away. It only adds, it only gives us more power. So we can see the title here is, well, exactly what I put in here. So for the scatter plots, there's some extra parameters. Well, basically we know all of them, or most of them. So we've got the size again of our dots. I can make them bigger, for example, put them to 40. Oh, let's see what happened here. There we go. I can make them very small. Let's put them to 4. So this is the size, but it's going to be squared. So let's have it be something like 20. I can also change the color, of course. Also, like we can do for our line plots and everything. And there's one new parameter. It's called a depth shade. Now the idea of the depth shade, we can kind of see here. Look, if you look in the back here, it looks like this one is more transparent, whereas these values here, some of these are very dark, and some of the ones are more transparent. So the idea here is that we add a shading that's going to help us give a little bit of depth perception, because basically what we're looking at here is a 2D slice of a 3D image. So we can never really see it in 3D because we're always going to be looking at it from one angle. So it's projected in 3D and it kind of looks like 3D because we can go up here, but really this is a 2D image because it's on a flat screen. And so the way that we give depth perception, or the way that Matplotlib would give depth perception, is by changing the transparency. So the default value, as we can see, is true because we've got different transparencies here and here. So if I change this, nothing happens. If I set this to false, then we're not going to have this extra depth shading. So everything is going to be the same shade. So this is one of these nice things that Matplotlib introduced that should try to help us differentiate different depths, basically, since we were looking at it from one angle, and so being able to differentiate this from here is a little bit more difficult sometimes, being able to directly say, you know, that this point is maybe more in the back down here, or maybe this point is like right in the front up here. Sometimes it's kind of hard to differentiate that. So the idea is to give it a little bit of this depth perception. But yeah, basically, that's it. So what we've seen is to add in 3D, really we just need to import this library, which gives our axis 3D capabilities. Then we have to add the projections, the 3D projections, to our axis that we want to use 3D on. And then we can just use the two-dimensional methods, adding in an extra Z component. And then for the scatter plot, for example, we've got this extra depth shade. But basically everything that counts for 2 dimensions will still count for 3 dimensions. So all of the arguments that we could use here, we can still use. It's just we have more capabilities now. Hey everyone, it's Max and welcome back. So in the last tutorial, we saw basically how to get started with 3D plotting. So we saw the importing of our 3D axes, and we can add 3D axis capabilities by just adding this correction parameter in, and then basically everything that we can do in 2D, like the scatter, and plot methods and whatever, we were just able to add another Z component, which gave us this 3D capabilities, which in the end looked like this. So one thing that I touched on last time is that we have this depth shade here, which allows us to see, or which is supposed to help us in seeing or being able to get some depth perception. Now, sometimes this angle of viewing may not be the best angle of all the angles. Maybe you want to look at this plot from a different angle. So that's what we're going to look at now, is how do we see this plot from different angles? So like basically, how do we change our camera? And to do that, we're actually going to do it down here at our scatter plot in the second one. So we're going to go into our axis 2, and we're going to call a method, or we're going to use a method called viewInit, which, well, as you can kind of guess, changes the initial viewing angle. And so basically what we're going to define here is like an elevation angle and a rotation angle. So that's what you can think of the two parameters that we're going to use here. So the elevation angle would be how high is our camera kind of going up? Like, are we looking at it from the top? Are we looking at it from forward? Are we looking at it from like down here? So our elevation angle is kind of like this going up and down like here. So that's going to be our elevation angle. Our rotation angle is this way. So do we want to look at it from this direction? Do we want to look at it from this side on, from this side on? So that's what our rotation angle is going to do. So for example, let's have 0 elevation and let's just have a rotation of 45. And so with 0 elevation, you can see it is a 2D plot because we've taken out one of the axes because we're now on 0 elevation, which just gives us 2 coordinate planes, and then there's one kind of going in through the back, but we can't really see that. So if we take a elevation of 30 degrees, we can see now we're going up, and we're seeing it more from a top-on view. We can even go even more up, say 45 degrees or something like that, looking at it more from the top, or 60, which is an even more top-on view. Yeah, so that's kind of what the elevation angle does. Let's go back to something like 30. Now, the rotation angle is going to be this kind of left-right rotation. So let's say if we go with 15, we rotated this way basically. If we go to like 75, now we're rotating this way. Of course, this is relative to 45. So if we start at 0, and then we just kind of work our way up, like 15, then we're always going to be rotating towards the right. So we can see we're slowly getting, we're slowly getting different viewing angles in here basically from different rotations. So yeah, this is how the elevation and the rotation can be changed. And yeah, I mean, it's nice because sometimes, especially like, let's say we started at 0 here, this really isn't a good place to look at things at because everything is just in a line and we don't know where things are. So in these cases, it's definitely better to be able to change this viewing angle to get a different perspective. And it's also nice because you can run the plot and you can look at it from different angles, or maybe you put the same plot into, 4 different, maybe you'd make 4 subplots and you have the same scatter plot in these 4 subplots, but you look at them from different angles. So that allows you to get a better perception of this 3D data because we're kind of limited because we have to look at it on this 2D flat screen. And so being able to get this 3D perception really only works if we can look at it from multiple angles. All right, so that's this viewing angle. There's another really cool thing that I wanted to show you guys, which is we can animate this viewing or this whole plotting thing. And so I'm going to show that for the angles. And we're going to make a for loop, and we're just going to loop for angles between 0 and 360. So we're just going to go in a circle once basically. And every angle, so we need an in here. So our angle is going to just take on all of these values. And what we're going to do is at each time we get a new angle, we're going to look at it from a new angle, from this angle. So we're going to go into our axis 2, and we're going to call this viewInit method. And we're only going to change
right now the rotation angle. So technically, you could have like the angle here, in which case you would kind of be going like a diagonal around, something like this. If we have a fixed angle here like 30, then you're always going to view from like this direction inward. I mean, I can't really show you with the mouse, like kind of like this direction inward from where our eyes are in towards the plane. And the angle that's going to change is we're only going to go kind of left and right, or we're going to go right around the whole plot. Of course, you could keep this one fixed and say we're looking at it from this angle, and then we're just going to go up and down, over and under this plot if we have this parameter changing. Or you could make two loops where you have like an angle 1, and then you do like for angle 2 and blah blah blah, and then you can have like angle 1 and angle 2 here, and you can make both of them dynamic. So depending on what you want to do, you can change all of this up. So this is basically what I'm saying. This is just a for loop. All right, so what we're doing now is every time we get this, every time we take on a new angle, we're basically changing our viewing angle. The problem with this is that for loops go really, really fast. And another problem is that just because we change the angle, it doesn't really update. So we know that everything we do before we call this plt.show, we don't see it until we do this plt.show, and then the kind of final conditions that we're in are going to be shown. So basically what we would have here is we would change our viewing angle to 3045, then we would go from 30.0 to 30.359, and then we would just see the final angle at 30.359. So that's not what we want. We don't only want to see one image, but basically we want to see the image or the plot at every single point. So to be able to see it at every single point, what we're going to do is we're going to use a new method called plt.draw. And this updates the whole thing. So this show, well, it basically shows it, and then it kind of, like clears it, and it means that we're done with it. But this draw allows us to take what we had before, and then we do an update to it, like we do here, and then we draw it, which just updates the current image that we have. So everything we have before gets saved, and basically we have all of this. Then we set the viewing angle to 30.0. Then we draw the whole thing, which means now we display it. So since we haven't displayed it yet, then we display it. Now we take on the next value, and then we're at angle 1, and then we draw it, which means we update everything. So now we just take on a new viewing angle, but we don't clear and all of this stuff. So there's still one more problem that we need to fix, which is this loop is going to go really, really fast. So we want to be able to slow it down a little so that we can see things. And to do that, we're just going to call plt.pause, and we can just put in here a short interval, something like 0.01 seconds or something, and it's just going to have a short pause every time in between this loop. So basically what's going to happen is we're going to take on a new angle, we're going to update it, we're going to hold for a second, or not even a second, and then we're going to go through it again. And this is going to kind of remove that problem of we just zip through the whole animation in like no time at all, and we have a little bit of, well, viewing time basically. Now the thing is, I can't use the IPython console for this. I actually need to use the Python console because it's going to allow me for animations. So if I run this, then here I'm going to get this external pop-up that's going to happen, and you can see the effects here. So our 3D line plot up here doesn't have animations associated with it, and so it's not changing, but our scatter plot down here is being animated, and so we can see it moving basically all around, but we're keeping our same viewing angle. Yeah, so that's how we change the viewing angle, and then this animation stuff is really cool, especially when we're doing this 3D plotting, because it allows us to get that extra perception of the extra dimension that we need, because we're kind of limited from our 2D screen, from our 2D point of view. And so, yeah, animations are really cool, and they're also really cool to show too. So it helps you do more data analysis, because you get a better understanding of the data, and you can actually see it better in all of space. but also it's pretty cool to look at.